Oh, am I even... Okay. I didn't really check if everything worked, but I think it does. I think it does. You know me, I don't check if things work. Okay, I stayed up to like 3 a.m. last night working on this, so yeah. It's pretty cursed, but I got it working. I am at we are at 30 FPS for 3 channels. 3 channels, Flow Linear, 3D on Windows XP. So, never thought I'd see the day, but here we are. So, what's next? 30 FPS is a pretty big, it's a pretty big thing for me. I didn't really think that I was going to actually ever get to 30 FPS on this, but I managed it. So I threaded everything last night. Yeah, it was like an insane amount of work, but I was obviously like not in the best mood, and so I didn't stream it because I was kind of at the end of yesterday I was kind of crashing the fuck out because of the toll it was taking on me. But I did eventually crack, and I just straight up asked AI, like, how the hell do I get the threads working? And it literally was like, okay, you already know what the problem is. The problem is that the threads are doing the job 2 times. And so all you have to do is make an integer that, asks if it's done the job yet. And so I was like, that's so true. Yo, what's up, Costcode? That is actually so true. And so I just did that, and then, it worked. Now, why that isn't automatically, like, a thing that you can implement that's, like, implemented yourself in the library? Like, why do I have to do that myself? I have no idea. It's, like, it's beyond me why set event and reset event, there's no, like, automatic blocking on if all threads have received the signal. Also, wait for multiple objects on an array of handles does not work. It actually doesn't work. They say in the documentation that it works, but it actually doesn't work. And so the correct architecture is to just have a single handle, which doesn't really make a whole bunch of sense. Oh yeah, this one's sick. Anyway, so we can optimize this a little bit further by there are some things that I can optimize in the code. We did the SOA refactoring a bit, not efficient, and I can make it more efficient by having another buffer. The issue is with the FFT stuff, it's grid, it's a channel major. For cacheways it should be grid major, and so I need to swap it to that. It does look like an atom. Yeah, that's the whole kind of point behind it. And then it'll always end up the same shape. Isn't that so cool? That I populate the field with a bunch of randomness, and then it always collapses back into one pattern. It's kind of amazing. It does take a while to get a cool pattern like that, but if you stay here for long enough, kind of traversing the parameter space, you eventually always get to it. Yeah. These sorts of things are also cool. Anyway, yeah, the whole point of Flow Linear is that we basically we're taking different our difference in mass, and we're basically moving it around. It's way more complicated than that, but now I want to build an engine yourself. Yeah. I mean, this honestly didn't take that long. It took like a week, but it would have taken like a month if I had never done it before. Like, I made Lenia in 2D before this, of course, so I got to basically, like, you know, I had the cheat code of already kind of knowing how it works. And also the flow linear stuff would have taken me, I think when I first did flow linear, it took me like at least like a week to just transcribe the formula because it was just so confusing. Yeah. Anyway, I think it's sick. I never thought that we would hit 30 FPS because we were so slow. But a few big parts of it, when I was threading it, I looked at this this roll function, and then I realized that we didn't use the whole grid. And so now what I'm doing is I'm approximating that here. I instead of rolling the whole grid, all I do is I apply the offset for the offset row, and then we just loop through it here to find all of the affected places by using this destination, or by using the source, right? And so we save out a lot by just not like rolling over the entire grid. Like the old roll function was this, which is technically, like, mathematically what the NumPy stuff is doing when I transcribe the formula, but it actually isn't necessary because we don't use this whole new grid. We only use the portions that are affected, because what the old loop looked like was that you roll and then you calculate the border, and then you loop through, but you only are really adding this, which is only the cells that got affected inside, because this right here is, you know, it's only based on certain affected cells. It's not the whole thing. So anyway, I don't think it's perfectly emulating what it was before, but it got us, it's now a third of the time that it took before, which is enough for me to be happy with it. I mean, that also has to do with the threading though. Like, the threading also is a huge thing that is. So if I want to show off what the threading looks like, I've learned a lot about multi-threading throughout this project now. Like, I really did not know what I was doing before, and now I kind of do. And so this is kind of the loop, right? And so for our first Sobel, what we do is we have two events that we are just swapping back and forth, right? So we set this event, and then this signals to the thread to start. The issue that I was running into before is that I would signal for the threads to start, and then we would get out here, we would set the done event, and then we would come out here, and then I would reset the work event, right? The issue is that in that time span, the other thread could already start doing the work event again before you can reset it. And so what you end up having to do is you just need this. So this is what I was stuck on yesterday for like 3 hours. It's this. You literally need just a number that is incrementing with every new you know, iteration, every new event. You just need a number that's incrementing, and if the threads generation equals this number, then you just skip out because you already did the job. And I don't know why I didn't like think of that, to be honest, because I was like so caught up on like the fact that this isn't like a built-in thing in the API. Like, I don't understand why it's not, to be honest. It's very, very annoying. But anyway, this is all of our multi-threaded stuff right now. So our Sobel convolution in both of the ones that we do. We do one that is for the sum, that's just once, and then we do one per channel. And then of course this is the rendering stuff, we already know that. And we have the reintegration step, which is what I just covered. And if you want to see the breakdown of the time span, this is what it's like right now. And so reintegration is absolutely still the most by far, but if you remember, it used to be much more. It used to be 0.06, I believe. I'm sorry, I have root beer today because it's actually almost my birthday, and so my sister got me some root beer. Anyway, so Sobel and then our reintegration. So they still actually dominate the time. Is that C++ or C? It's mainly C. I don't really do a lot of C++ stuff in my C++. It's mainly C. What is said? What is said? Anyway, so this is our rendering time is 0.017, and then our reintegration is alright, so these still dominate the space, but I have the idea now to try and do what we kind of avoided doing yesterday, which is one, getting everything in row major, in grid major, I mean, which a lot of it is, like this is, right, this is, all of this is, so all of this is good, and that's why ComputeF goes fast. This also is fast. Yeah. This is kind of annoying though, but it's necessary, I guess. Okay. So, this also, oh, so this we also already did. Okay, so literally it's just this that's channel major. It's literally just this, and it is in the, you know, the hottest part of the loop. And so, also this doesn't need to go into this. This can go into the regular array, because they all should be separate now, because this is destination is based on the sectioned off part for the thread. So this can go into the, where would I put this? I think I was putting this into back, right? Yeah, but I can't put it into back because that's okay, so let's look at our variables so that I can figure out what this should go into, which buffer. I think it yeah, it's kind of hard. I can't really reuse anything. Oh, what's up, yo? Buo. I wonder if I can put it into here. I could definitely reuse this buffer. I think. Oh, it needs to be zeroed though. I wonder what would be faster, me mem setting this, or if I just make another buffer. I think I might just make another buffer. Yeah, root beer is based. Well, never mind the name. Yeah. So instead of doing this, we need to put this into a grid major, and then this can go into another grid major thing. Okay, for simplicity's sake, let's just not reuse it, and let's just go okay, so all we have to do once non-native English yeah, sorry, I'm stupid. All we have to do once a frame is put that into the other thing. So I'm just gonna call this yeah. And so all this is going to do is it's going to loop through yeah. So this is going to be cells I dot grid equals cell FFT index by C dot val I. Yeah. So that's just it. Of course, that, right? Yeah. Is this project open source? Yeah, I'll put it up on GitHub later. I'm going to transpose also back. Yeah, so we're going to transpose back. We will be putting it into back. So we want to transpose back into grid. Wait, no. Yeah, into val. I mean, also this has to be the real part. And then here, we also have to make sure to do this equals 0. Okay, so now we just have to transpose once, and we can do so from the main thread. And this will be transposed to row major, and this transposes so that we can FFT things properly. So we just need to transpose after here. We transpose to channel major. I'll add it to the header in a second, but then we transpose to row major after the reintegration step. And we don't have to accumulate anymore because of what I said earlier. Okay, so this is going to be to row major, and we'll put it in the header. Okay. So we don't need to accumulate into here anymore. What we can do is just go straight into back. So this is going to be destination back C, and then we're adding in what we just transposed into channel major. Yeah, like that. Don't I stream on Twitch? I do not stream on Twitch. Only reason is because I don't like, you know, splitting up my audience or whatever. Is the project ain't on GitHub though? Not yet, but, you know, in like a week it will be. MIT wrote the thing for 3D in JavaScript in language that looks like Regex to end user. What you're doing is completely insane. Thanks. I appreciate that. Yeah. So that should technically be faster. I don't know. Yeah, so this is gonna have to be... Yeah, we do have to memset that, unfortunately. That is necessary. Which does suck. I don't think that we can get away with it. Oh, and the annoying thing about this row major, grid major thing is that we can't actually memset that stuff because it's so not contiguous in space. So what we actually have to do is just set it here, which actually this is completely fine. Yeah, there we go. Yeah. Now let's see. Okay. Okay, I think I just actually lucked into doing it correctly the first time, which is kind of bizarre. I usually don't do things right the first time. I want to actually, this one is 4 channels, right? Yeah. So let's see what the time is like. Yeah, I've got to fix whatever this thing is where it doesn't close when I press escape. I don't know why that is happening. It was not happening last night. What's its complexity? The whole thing? I don't know. Pretty fucking complex. Yeah, so that didn't change anything at all, so fuck me, I guess. Well, you know, theoretically, it's faster. Theoretically. All the systems engineers would be like, oh my god, the cacheways, bro, the cacheways. Whatever, bro. Whatever is what I say to that. Okay, let's get rid of all this ugly code. Yeah. I mean, yeah, technically it should be faster. Okay, so we can get rid of some of this stuff now. I was also trying to figure out why this doesn't work. I couldn't really figure out why it can't align, but it's probably something to do with me programming this on Windows XP or something. But yeah. Where's my thread data? My structs are all over the place, I know. Okay, so this TD data can actually straight up go away now, which is pretty sick. That is pretty sick. Because now we do the whole thing in line, which is pretty neat. Now as far as doing this in Simd, worst case would be n squared, n minus 1 divided by 2. Yeah, whatever you say, man. That sounds good to me. So yeah, I'm not sure how to do this in Simd. I'd have to like look it up because I don't do Simd. I don't know if that's what we want to get into today, if we're gonna get sidetracked like that, but yeah. We should also implement this border torus thing. I can like transpose this to be in line as well, I think. So this is This is the pause array. Minus the mirror. And then you're capping it. Got it. Okay, that sounds good to me. Alright, so let's do that. Okay, so how do I do this? So the pause array will be indexed by, this is I, and in that case, this is destination. I already did this yesterday, but I need to figure out, yeah. I think that should just be it. We can switch the border to test. I never liked the torus border on this, but yeah. Maybe I just never did it right when I transcribed the formula, but this is what I read back in the day when I did it. Okay, well, what are we mad at me for? I mean, I just added one line of code, man. Oh. Data is not a member of TD. Where are my... Accumulate reintegration. Okay. Yeah, I mean, this formula just... This doesn't even need to exist anymore, so we can just get rid of that. Okay. Okay, so this doesn't need to exist anymore, so we can just get rid of this as well. Okay, I don't want to like delete the whole code base though, because I don't really have version control, so we're just gonna do some of this. Okay, this appears to work. I'm not really sure what the torus border exactly is going to look like, per se. Oh, wait, I'm so fucking stupid. Oh my gosh. I'm so dumb. I've stupidity all over myself, dude. I need to actually change the border. Duh. Duh. What? No, I don't need it. Yep. Don't need to send an error to Microsoft, bro. Okay, theoretically, it should be different. Okay, I mean, to be honest, it seems the same. It seems like exactly the same. Sci-fi? Yeah, sure. It does seem exactly the same. Maybe I can't do the torus border without the whole rolling thing. Maybe I actually need to... Please upload the source code? Yeah, when it's done. It will be soon. Oh no, this is the code that I used, like, All it's doing is capping. I kind of wonder what this is like, but can we color the different components? Yeah, I already have that implemented, but yeah. Alright, let me do the border wall clipping. That's actually a good idea. So let me bring up the other code for that. Okay, so this is, so when I compute mu, if border equals border wall, we are clamping this, all of the IXs between this. I never understood this width minus sigma. I never understood it, what that is, because sigma is always going to be negative, or is always going to be like 0.5. So that being yeah, it's weird. Also, yeah, so that, and then this is just oh, sorry, no music right now. Okay, so I don't know if that's working, but we can try it. That's what I had. Maybe I transcribed that wrong a long time ago, but we can still communicate in less than 1-2 seconds. Yeah, that's incredible. It is incredible. Okay, so let's give this a shot, I think. Yeah, I don't think that this thing is correct, the border wall. I don't think that it's correct. I have to look at the code again. I just don't, yeah, I don't think that that's correct. That is the power of optical cables, yeah, for sure. Okay. So let's change our border back to none, and I guess now that's done, so that works good. So yeah, unfortunately, I think that we're kind of really as fast as possible. I mean, yo, what's up, Mano? Ever think of making my own server? I haven't really. I have not really. We can keep this. We can keep this here. I don't know if the compiler is just gonna make this automatically a thing, but I guess it's just good practice, you know? Yeah, I don't know how to do simmed. I'm not even sure where I would do simmed, though, is kind of the thing. Like, all of this stuff is already so fast, where it's, like, probably already vectorized, to be honest. I guess you could do simmed here, like... You still need to clamp this manually, right? Maybe I'm just dumb. But... yeah. We also get, like, backed into an architecture if we do that, so maybe we just stay away from that for now. We could also technically multi-thread F, but I feel like the returns from that are so tiny. Reddit? Yeah. Yeah. For sim for portable simmed? Yeah, I feel like, yeah, it's just like kind of defeats the whole purpose though. Yeah, I mean, looking at the code right now, like it's just not very simmed like friendly at all. Maybe can you do modulus in simmed? I've never even checked. I usually just do the multiplication or whatever in simmed, but we also can do the complex multiplication in simmed. I can look at how I did that. I already did that the last time I did this with the where is it? Is it here? No. Where do I do this? I didn't do it already, did I? Oh, here it is. Oh, it's just done in line like this, so it looks weird. So we could do this with simmed. I just feel like it kind of defeats the whole purpose. It's not very simmed friendly because of the way it's indexed, but it has to be indexed that way because of FFT. So alright, I'm looking at what I do here. Yeah, so I call it on every... So the reason why this is confusing is that I do Huh, hold on a second. I actually don't need to do this per channel, do I? Wait, no, I do. Oh, hold on a second. No, yeah. So I just loop through the channel. Oh, yeah. So this is the same thing. Actually, so this is supposed to be this then. That's supposed to be that. Oh, shit. Yeah. It is going per channel. It's just not necessarily looping. Yeah, there's no need to actually loop here. At all. I don't know why I didn't see that before. It's just you don't use C. You just use int channel in C equals the kernel C0. I don't know why I didn't see that. Hey Neural. What's up? Got it. Okay. So yeah, that was an unnecessary loop, but I mean, I don't think that that's like an incredibly big change. But we can see what that looks like, I guess. Yeah, it's a pointer. Well, that's interesting. I've never seen a pattern like this. Yeah, it definitely does not have portable simmed in here. It would especially be weird because, I mean, I'm stuck between it, you know, a different CPU architecture than my OS architecture. Obviously, Windows XP is 32-bit, so it's not. I don't even know if it's worth doing, to be honest. To be honest, it's probably just like auto vectorized anyway. In my case, I just don't think that we're gonna see like really diminishing returns from doing it. But I mean, technically, we could do it here. We could do it here. Vector math library. Yeah, I mean, I've written one for my game engine. Yeah, but yeah. So this is. So the way I did it here, or the way I... So you're looping this way because you're loading two in at a time, because you're loading this and this in. Yeah, I have no clue. I do not remember what this is like, but let's try it anyway. So this is going to take in the title of the stream is 4-panel display, which is what I was going to do today, but now I kind of am like wondering, can I do it better? So we actually go plus equals 2, and the reason is we are... Wait, hold on a second. Do I even have these instructions in here? Oh no, I don't, because I'm SSE. Why am I passing pointers for my complex in and out? Why not pass them using actual values? What do you mean? This is a pointer to an array. What do you mean? No, we're passing the entire thing. Why would I want the function overhead of passing 2 floats at a time? This would you would call this like what, 32,000 times a frame, this function? Why would I want the why not just do this? Why not just do this, pass a pointer once, instead of copying the memory? That makes no sense. A complex is 2 floats, yes. Okay, yeah, so it's a different... Yeah. Okay, so this is different. Maybe not, actually. Thing is, I'm probably gonna get this wrong a billion times. If you make it just the values... I don't see the point in not just looping through it in the function rather than looping through it outside of the function and calling the function a billion times. Trying to find the loading. Okay, so it does have what we need. So this is so I think it's instead it's M128 now, based on what I see. I've never done this before, by the way, so, or like, you know, seriously done this before. Okay, so that's not coming up. Oh yeah, it's probably because I need the header for it. Yeah, duh. What's the name of this again? I think that this is available. Yeah. Okay, well maybe it's not. I think that this is Intel only though. Right? That's Intel. That it's E. It's E. Okay. But this is a real thing. Okay, so this is a real thing. Okay, got it. Okay. I'm trying to find where the floating point shit is. Like it's only where are the floating point types though? Like this is what we're looking for, but where are the floating point types? Unless I'm stupid and there's like some macro. Oh, maybe it's this is a oh, this CRT align is what we were looking for, by the way. That's what we were looking for. Okay, so here's the floats. M64. Yeah, but there's no oh, there is a floating point in here. Okay. And then there's doubles down here. Okay. Searching on the search bar, I'm good. Okay, so I think it's this, and it's this header. Okay. Okay, so this is, I just need, I don't think I need to, it's automatically going to be a float, I think. I don't think that I need to specify that. Okay, so let's see how I can load. Yeah, I'm gonna assume that this is going to be a disaster, but at least I tried. I need to read. I've been trying to read the fucking computer systems, a programmer's perspective, but it's like 1,000 fucking pages, man. I don't have the fucking patience for it. I think I used this. That's what I had. Don't really remember the difference. Floats 32. Okay, got it. Yeah, I was confused because they've got all of these. But actually, no. I should be using 64. I should be using 64 since I'm loading in 2. Yeah. I'm done. Okay, so this is 64, and then is there no vector library? I don't code with external libraries. This is exactly what I want, but how do I load 2? Oh, I guess, no, you can't. Wait. You can load 2, though. Yeah, maybe I need to read a book before I do this shit. Okay, so I just got my question answered by Google. You can't, apparently. It doesn't allow you to load two 32-bit floats into a 64-bit. You have to actually do a 128. So that answered my question why there was no load. So you have to do this. This is the way you're supposed to do it, right? This is the function. No, you don't have to put 128 on it. Okay. I think that it's, yeah, so this is fine. I wonder why this why it says that this is undefined. But this is going to be yeah. Okay, let me see why this is undefined still. FFTW complex to const float pointer. Yeah, what I should do is I should just literally cast it. Yeah. This has to be able to cast, right? Yeah. Okay. Got it. Okay, so load PI apparently does 2. Alright, good night, Shari. Hey, Robbie. It's not defined. I have to... So, I mean, I don't have a P... Yeah, so all I see here is that there's just... Load 1 PS. That's what... Wait, but that's just an alternative name. I'm so confused, dude. I need to... Okay, so this is what we want. We want to load to... But we can only do it with doubles. Are you serious? You can't do it with floats? That's crazy. That's crazy. That has to be possible now. You can only do it with doubles. And this is what I had before, was this. Got it. Well, you hate to see it. You hate to see it. There probably is a way to do it, I'm just too dumb. Last abbreviation is just precision. Are you talking about... Are you talking about here? I think this is the function that we need. But... This is... Oh, hold on a second. No, yeah. Okay, got it. Okay, so it is this. Thank you for pointing that out to me. This is just the register. Wait, but then why is it a double pointer? Why don't they have it like void pointer or something? I don't know. That's so confusing to me. That is so confusing to me. Okay, but yeah, this is why I'm not hired as a systems developer. That's for sure. Okay, so I think this works now, right? This is a function that we can call. Yeah. And so instead of casting this, you're gonna... Wait. Why is it telling me to cast it to 64? I should cast it to 128. Yeah, I'm casting this to 128. Why would I cast it to 64? It's asking for 128. D. Or maybe I have to cast it to 64 because if you don't, then it'll skip over the data or something. Yeah, that's probably why. And now I have to specify the register thing. Yeah, I did take a look, Neural. I did take a look. There was no load for you see? There's no load. Why am I doing Fourier analysis? I'm not doing Fourier analysis. I mean, it just uses Fourier to simulate. I think that this works though. Let me check what. So the weird thing is that I didn't put another argument here in my other code, but maybe I was using a different thing or something. Okay. Actually, maybe this is possible. Okay, let's do this. Let's do this. Okay, I've decided we're just gonna do this. And we're just gonna run with it. Okay, so we're gonna do that. And then I'm just going to give it this. It's actually so strange though, because this is... Okay, maybe I should not be doing this right now. Why do we cast anyways? Because that's what it's telling me to do. I think we're casting because we need to tell it how many bytes is each integer. Because if you give it a 128, then it needs to read in the whole thing. But if you give it a 64, then it's gonna read in two, in stride, right? Because actually this has to be 32 then. But we can't do that. Yeah, I don't know. I don't think, yeah. I don't know. I mean, the example that I'm going off of literally does it, so that's why. Maybe it says load HPI. Yeah, it's gotta be one of these. Yeah, I mean, you're really smart, man. You're really like the smartest out of all of us. Like, truly, it really like. Okay, man. Like, sure. Okay, we're just gonna do this. And, okay, so is the first part the, I think the first part is the thing that you have to set 0. This. At least that's what I'm reading. Feels like load UPS is fine though. Yeah, I thought so, but I wanted to try and load 2 at the same time, like I was before. So I'm just gonna try this. I doubt that that's going to work, but that's what it says. Okay. So we're just going to do that for A and B. Wait, but I can't set 0 here, can I? You know what? I think I'm just going to trust my own code here, and I'm just going to use load u PD and then just cast it to const float pointer. It's just weird that it doesn't, you know, whatever, that it doesn't specify 2, but I guess 128, it's weird. Or does PD mean double? Is that what that stands for? Maybe that's what that means. Oh, PS is single precision. Oh, that makes a lot of sense. Oh, okay. Well, that's why I was confused. There we go. Okay, well that makes a lot of sense now. Got it. Okay. Well, I learned that today. Okay. So, if that works, how do I actually test if that works? Okay, so I can just get it out with the... Okay, so this loads it into the low bit, so that's why this this is the low, the unpack low, and then that's gonna be PS. Okay. Okay, but then how do I get the... This is interleaving. Yes, that's why I did PS, because single precision. No, this is my actual machine with Windows XP. I'm gonna segfault? Why? I need to get the real and imaginary out of here. So okay, so let's just get it out of A0 and B0, I think. And then let me just store it in results and then read out just to make sure that we're not doing this wrong. Let's just store it into out. Oh, you have to give it, because it's doing 2, you have to give it a pointer. And apparently you have to cast it, which is what I did before. Because it's void. Oh yeah, because you have to cast it because of FFTW complex. Okay, and that's what I did before, basically. So I'm just going to step through it and then see... Oh wait, I have to call the goddamn function. That's something that I have to do. Yeah. To call the function. I'm just gonna call it here. Okay, so this is gonna be yeah, that's just this and the kg and the out will be the temp. It doesn't matter because we're gonna overwrite it, but yeah. Okay, so let's just see what it gives us. Okay. Okay, but why does my breakpoint not want to... Like... Can I not breakpoint this? It's like literally, it's illegal for me to do so, apparently. Well, that's a problem. Oh, wait, you know what? Hold on, let me try going into debug mode. So maybe it has to do with that. Okay. Okay, so we get result is 0010, and we put in 1 there, and this should be 00. Oh my god, fucking... Okay, so that's perfect. I don't know why it... Okay, no. It does. It's just auto casting for us because of the union thing. Okay. So there we go. It works. Okay. Cool. Okay, but now we need to actually multiply it. Okay. So stop meaninglessly casting. You need to cast this. Because this is FFTW complex. And you need to cast it. Okay. High and low bits? Yeah, that I think you can keep them both in low. Here. I think you want to keep them both in low because of the other operations. But I'm not sure. Okay, let me go through the rest. So, okay. Or maybe I'm wrong. Wait, hold on a second. I think I'm trying to actually load in 4. At once. At least that's what I did on here. So we're loading in 2. But that would be this. But I think that you're supposed to try and load in 4. Okay, so let's figure out how to load in 4. Because we can load in 4, they're contiguous, so how do I load in 4? Or maybe this already is? I just have to do 256. I think that's why I had it as 256. But I don't even think I have the 256 header is the problem. Like, that's the problem, is I literally can't do that on my CPU. So that's why we're doing it this way. So we have to actually do it 2 at a time, unfortunately, I think. Fix the Windows crashing? Yeah. A great program. How many leak code problems? Not a lot. I don't do leak code. Does XMM have a way to separate? I don't know. I think so. I want to go through just like what I did before. So what I did is I just did mul pd, and so this would be mul ps now. Yeah, so this is... Is this not a thing? Can I not do this? What I had written was this, basically. Let me see where the mul is. There definitely is mul inside of this function. Mul ps. Okay, so it does exist. It's just not coming up. Okay, so that's exactly what we want to do. So I'm kind of wondering what that does. I think it just multiplies. So it multiplies the first times the first, and then the second times the second, and then it puts them into the bits, right? And so we can test that. Let's just test that, because I'm kind of like interested to see if this is correct. Okay. Hold on. It might actually be... Okay, well... Okay, never mind, I guess. Okay, but to be fair, A0 is just zeros here, so... Wait, why is A0 always 0? Okay, well, I think our... Okay, well... Okay, well, I can't test this if this doesn't... Bro, I'm always good? Yeah, I'm always chilling. Does the CPU have AVX now? Or maybe it does, but I don't have the header for 256. Anyway, so I think that this works. It's just that this has no data in it while I'm trying to debug it. So let's just... Does it do you have data now? Okay, you do. See? Okay, so let's do it by hand, right? So this is 2003, and then this is 0.9, right? And so this is... So yeah, so the first value is that A. So it's the first value times the first value. I'm not sure what the other ones are. I think that they might be garbage values. What CPU am I using? I'm using a AMD FX 4000 series, I think. Pentium 4 computer. Yeah, I mean, mine isn't like exactly era accurate, because I just, I took the computer that I had in my garage, so. But I mean, it is old, and it has drivers for Windows XP, so it's old enough. So 1 is 0 because obviously the A, this is 0, so it just does 0 times 1 times 1. The thing is, so the high word is just garbage memory, I think, because I don't think that it zeroes it for you automatically. So I think that's what we're seeing. So I think that it's working. The main thing here is not just like me getting the code done or whatever. I just kind of want to learn how this works, so that next time I don't have to just like, try and figure it out from scratch again. And like a lot of my interest lately has been trying to understand memory layout and shit so that, you know, I'm not like a useless fucking programmer, you know? So that's what I've been trying to do. And then here I had something like cursed written. This is like some Stack Overflow copy bullshit. Like, what does this even do? Oh, I see what this is doing. Okay, so I don't know why this is what this does specifically, what the binary does here, but I know what it's doing. So if we look at our complex multiplication, actually is like, okay, so here it's what it's doing is we multiply 0 times 0, 1 times 1. You see, 1 times 1. This is how the complex multiplication happens. And then down here, what we do is we need to swap them, right? And so this becomes 1 and this becomes 0. And so now we're multiplying the other way. And so that's what that's doing. So that's what shuffle does, is it switches the high and the low bits. This is a very confusing thing, though. And I'm wondering if we need to change this because of floating point. And so I want to look at that now. So shuffle PS unside it IMM8. Let me look that up. Shuffle floats IMM8. Okay, so it's apparently okay. So the first bit, okay, so it's a bit mask. So the first bit, which element from the lower 128-bit lane goes to the first destination position? Which element from the lower 128-bit lane of the first? Okay, so so would it be the same if you wrote it like this? I think that would be exactly the same. Okay, so this basically, if I can explain what this is, so this is 8 bits, right? And so each one of these combinations is selecting which one, right? And so this is the upper two, and then this is the lower two parts of the register, right? And so what this is saying is it's saying I want this one to go to the bottom. I want this one in the top bottom to go to the bottom, or to the other way, to the top. At least that's what I think is happening. So I want to do some testing here and see if this is working like I think it is. Is that 8-bit? Yeah, it's an 8-bit bit mask. But this is just written as the bottom 4 bits because we're not using the top 4 bits, right? Okay, so let's test this. Let's write out BR here and then just like see. So this should swap the bottom and top of BO. Yeah. One failed. What failed? Bad suffix on number. Do I have to cast this? I might have to cast this. What's the type? Unsigned int. I might not be able to write it like that. Bad suffix on number. Can I not write it in line like that? Bad suffix. Let me look this up. This might be like a old compiler thing. Oh. Okay, so I have to do you, I think. No. No. Okay. Okay, so the you know what the fix is when you search this error up? It says upgrade your compiler. It says upgrade your compiler. No. This is a compiler issue. This is just because the computer is old. I literally can't use the syntax. So I have to write it in hex. So, yeah. Common fix, not available. Use modern compiler. Okay. Okay, I don't know how to write hex, to be honest, so I'm just gonna look it up. sorry, hex guys. I'm just gonna look it up. Okay. Okay, so we did it. So we have 110. See, so 0011. Okay, and BO coming in was 0101, and B coming in was 10. Or are they both? No, that, wait. That doesn't sound right. That doesn't seem right. Hold on. If it's 10, 10, then we want to swap them. It should be 01. But instead it's 00. And this goes up to here. Okay. Well, that didn't work like I meant. Can we define so that we pass that macro? Yeah. Can do that, yeah. Can do that for sure. But I don't, so this isn't correct then, though. So I think that we might have to use a different thing. This is 10, so it should be 01. Oh no. Yeah. Shit. 0, 1, yeah. So this went up here. I don't know how to write hex, man. That's the problem. That's the problem. So okay, so let's actually, so yeah, okay, so let's read this. Okay, so select which element from the lower 128-bit lane of the first source goes to the first destination position. Second destination position. Okay, so we should try switching it. We should try OXA. Yeah, I totally figured that out myself, not Google. Okay. Oh, shit. Let it cook. And take it out the oven. Okay. So okay, BR, Brazil. Okay. That's not it either. OX1B? Okay, let's try it. I don't understand how to swap them. I just pressed F1. Oh my god. Every time I press F1, it's just cursed. Okay. So let's try that, I guess. Dude, I don't know. This part is weird. Wait, no. No, wait, it's 5. Yeah, exactly. What are you smoking? Yeah, this is exactly this. Wait. Sorry, I just got super loud. Wait, you just did it. Wait. 0.99? No, fuck. No, fuck, they're backwards. Oh, god damn it. Oh, shit. Okay, so here's a question. We gotta think critically about this. So, is this the low? This has to be the low, right? 100%. So then wouldn't it be 0, 1, 1, 0? Like, I feel like that makes sense to me. It has to be 0, 1, 1, 0 because fucking shit. Fuck. Dude, like, why is it going to the opposite end? This is like, this is going to here. And then this goes to here. Maybe I'm supposed to go to the other side of the bits, but we're not even using the top. Okay. Okay, let's try. See, the thing is, this has to be. Oh, load U is upper, right? Wait, load U is upper, right? Wait, hold on a second. Is that upper? Okay, so this is 0, 1. Or no, it's 1, 0. And we have 1, 1. Dude, this is crazy. Rob, you know I can't copy that. 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 Alright, we're doing it. Alright, we're writing it. We're writing this macro that Rob made for us. I was supposed to be making the 4-panel display today, and then I was like, oh, you know what, let's just try to do some like little SSE. It'll be fun, little SSE. This reminds me of when I was like a kid, and I would go to school, and then like in biology the teacher would be like, you know, I would be like I would get to school, and then I didn't do my fucking like biology definitions or whatever, and we're like all sitting in the class getting ready for class, and I'm just like, you know, shamelessly like asking like my friends like yo, and then I'm just like under the table, and then the teacher's just there, and she knows that I'm copying it because like we got like 15 minutes before class starts, but there's nothing that she can do about it. Yeah. This is what that feels like. Okay, we'll try 0x05. We'll do that next. Okay. That's a macro that Rob made for us, okay? Okay, I don't even know what 0x05 is, but let's just try it. Just to make Neural happy. Ah, fuck. Where did I miss one? Oh, it's mad at me because I have to like do that, right? That's okay. Hey Arya, we're doing simmed. Don't be a smartass. we're doing simmed. Okay, 0011. Nah, that ain't right. That I'm just kidding, Arya. I'm just kidding. I just know that you're gonna. What's the purpose? Don't ask. Shut the fuck up. It's so okay. Okay, listen. So we can't do this syntax because our compiler is too old, so we had to make a macro, okay? Listen, you've never seen anything like this before in your life. Okay. So let's think critically here. I think I'm gonna go ahead and say that it's this. I think that this loads upper, even though it looks like it's lower. It 100% is lower, by the way. But we're just gonna pretend like it's not because this is not working. So we're what? Oh, yeah. My bad. B0? It okay. Hold on. Nah, that can't be right. That's 1-1. Fucking Christ, fucking Christ, fucking Christ. Okay, so hold on. 1. So we copied it. But we're touching the right data. We're touching the right data. So it has to be some permutation of this. It's either this or it's the other way around. It's guaranteed either that or the other way around. Guaranteed. Okay, well, it's definitely not fucking that. Yeah, it's definitely not that. Oh my god, bro. Like, why? Why does this not work? I feel like the documentation I read on this is just wrong. For whatever reason. Like, now both of them are 1. And now we got rid of the top bit. Okay, so if both of them are 1, then we definitely are moving it into the right spot. So it has to be this that we're moving into the right spot, right? So let's check that first before I lose it. Okay. The fuck are you talking about, man? Wait, why? How are they all 1? How are they all the same now? Wait, what? They all became this one. I have a full confidence that the macro's not correct. Nah, you're so right, though. Like, this cannot be happening. There's no way, right? There's no way, right? Okay, hold on. You know what we might... It might not... We might have to... We might have to, like, specify that this is, like, unsigned. Yeah? Yeah. Third argument is immediate value. So the third argument is an 8. Shuffle PS is supposed to take an I-32 instead of... Wait, what the fuck are you talking about? Wait, what? Are you serious? Wait, what the fuck are you talking about, man? Why is it always like this? Okay, that can't be right. No, that can't be right. Okay, Rob, this macro can't be right. This macro cannot be right, Rob. Dude, what a watch an Indian? This macro is not correct, Rob. Rob, the macro cannot be correct. Because this shit is getting duplicated 3 times. This number ends up here and here. That's not possible. At least from my understanding, when it's a 1, we're copying the value into a certain part of the register. So there has to be 2 of these. There absolutely has to be 2 of these in this macro. Either that, we need a 4-bit? No, we need an 8-bit. So half of the no, it's 8-bit. These 4 are the upper half of the register. This is the lower half. Okay? So this one selects the bottom is going to the first. This one says that the upper bottom is going to the first. This one says that the upper bottom is going to the second, or no, that the bottom is going to the second, and then that the upper bottom is going to the upper bottom. So that's why, right, if we want this to go like this, it would be this. This is supposed to be this. It was always supposed to be this, okay? Because lower goes to lower, okay? Bottom goes, yeah, it should be this, man, right? No. No. Yeah. So upper bottom goes to bottom, then bottom goes to upper bottom. It should be this. It should absolutely be this. There's no way that it's not this. But it's not, apparently. unless I don't understand how it works. I've read it like 5 times. (099) 094. (1100) is all it's going to do is copy the top downward, though. Dude, maybe I'm just too dumb for this shit, bro. Or maybe the macro is wrong. I don't fucking know, dude. Alright, Neural, I'm trying your... I feel like we just gotta give up at this point. This is ridiculous. 099? No. No. This needs to go here. It just doesn't make sense because I'm doing it all correctly. Maybe I have to make this unsigned. Don't say thank you for trying. Do not say thank you for trying. I feel like you could sit here all day and just like try out different combinations. How many actual combinations are there for this? Probably like Was it 8 times 8? That's not even that many. Yeah, apparently you can't do that. Because it's not a literal. It's not a literal. Hold on, I've got an idea. What if it's that? That? Zero 094. 099. Okay, so it's definitely not this. Okay, but 099 goes into the right spot, yeah? Yeah. So 099 goes into the right spot. So it either... Okay, so... Okay. I'm just gonna brute force it because this is fucking ridiculous. Okay. Okay, 099 is correct. Now all I have to do is get this to be 0, the other part to be 0. As long as I get one part correct, okay. Z 9009. Okay, there you go. There you go. Okay, we did it. Jesus fucking Christ. I never want to do that again. Why? Okay, so let's think a little bit critically here. Why the fuck is it this? Okay? Because this is bottom goes to bottom. This is top bottom goes to bottom. So why the fuck does... Okay. Listen. Don't crash out. Can I remove cast in you? Okay. Rob is just like... See, my macro did work. Now remove the cast, motherfucker. That's... Yes, you can. It's the same. I'm still not sure that the macro worked. But listen, we're not here to... Okay. So now, of course, we just have to multiply BM. Now we just do the same thing with AM. No. A0BR. Right. Because if we go down here, that's exactly what we do. We do this times this with the opposite, right? Okay, now, okay, I'm never shuffling ever again in fucking Sims. We're never doing that again. Jesus Christ, that was cursed. Okay, so now we subtract. Ah, shit. Okay, hold on. Let me see what the formula is. So we need to subtract 0 from 1. So we... Okay, so we need to... Okay, so this apparently subtracts both parts of the register, the high and the low, right? Because of 2's complement or whatever. We need a unit test. I do not need a unit test. That is the thing that I need the least in my life. You can use this macro under the MIT license. I'm sorry, I'll make my own version that, oh man. This is good, this is good. Okay, so this is gonna be the R mole, which is real mole, which is going to be mole, no, this is R sub PS AM apparently there's happy birthday. Yo, what's up, Hamish? H sub. I think that this is H sub. H subtracts the top and the bottom parts of the register, I think. I just don't know about the sign. It's supposed to be the real minus the imaginary, and I'm not sure if we have it in that order. Let me look this up. H sub PS. Horizontally add adjacent pairs. Okay, you're lying to me. This is a subtraction. What are you talking about? Horizontally subtract. Okay, well, they're acting like I know fucking horizontally. I'm assuming that that's the first minus the second, okay? Which is low minus the top. So I'm going to assume that we know what we're doing here. So this is... okay. So now we need to... I add, which is adding this part. And then we can do H add PS with... This is going to be... This is just BM and BM, right? Because we're adding the bottom to the top. Yeah, exactly. I want you, bearded man. I'm alright. I'm good. Okay. Oh, yeah, so we already have the results. We just need R sub and I add in here. Okay, so let's actually figure out, I think, okay, so let's take a look now. Okay, so apparently we fucked up. Oh, well, that's gonna be a problem. That's not good. Where's the horizontal addition for single precision? This might be a problem. We may have to do some ingenuity here. Okay, so I don't think that there's horizontal addition. So I think we might actually have to do it manually. Wait, hold on. Let's see. Does this add SS or add PS? I had a whole lot of money. I'd give you some. Weird chat today. Oh yeah, it's just it's my sister's friends. mm sub ps. Subtract packed I'm not sure. Add packed single precision floating points. Okay, so I'm gonna assume that this is horizontal, that this add PS is, because it kind of sounds like it is. But we are of course going to check the results. Okay. So what do we get? We get a bunch of zeros. Okay, well that's not good. R sub has nothing. Okay. Got it. Okay, so this is not horizontal. What we want is for it to, the bottom to subtract the top. And so since we don't have H sub and H add, I might have to actually store them into different registers. God, it would suck to have to shuffle again. That would really suck. Yeah, so this, okay, so IAD is 1965. Okay, so yeah. It's not adding the top versus the bottom. Yeah, so since we don't have AVX, I mean, yeah, it's going to be more complicated, which is so sucky. Okay, so I see. Okay, so you can. Okay, so there's a function called extract, where you can extract the top bits, and that's what I think we have to do. I have to look what ours is. Okay, well, I would love to know. Okay, I guess it works. Yeah, so let's just do extraction like that. The weird thing is that this example here has a has 128F, which I don't think we have based on what I see here. So I have to find, I see this PI16, but I don't know if that's really what we're looking for. We don't want unpack high because that's slow, I think. God, I wish I fucking read that computer systems book. That would be really handy right about now, huh? Okay, so apparently HL or H1 is what we're looking for, this one. Because it makes a new register and moves the top, the high to the low. So that's what HL is. It's high-low, I guess. And this is low-high. So that makes sense. Okay, so let's do that instead. Move high-low. I wonder why this takes in two variables, though. All these taking in two variables is kind of weird, but... so we want to take in AM. And so then we just R sub across, and then this should be equivalent. So let's see if R sub now is correct. Oh wait, whoops. I have to wait until we get so this is 0, 50. Wait, hold on. $166, and AM was, so this minus this is 166. So we did it. Okay, I think we did it. So if we follow this all the way through, this is 1627. So AM ends up yeah, okay, I think we did it. Okay, that was a lot less painful than I thought it would be, to be honest. Okay, so let's just do the exact same thing for the imaginary part. And then we'll just add I high, and then yeah, I add. Okay, so let's see. Okay, it's a lot of math for me to like walk through it, to be honest, but so AM was, so it's, if the low is that minus that, then it should be adding 146, so that's like 28, right? That's correct. It's annoying because this is like backwards, right? It's going the other way, so it's confusing. But so 155, 15, 311, negative 30. Yeah, I've got no clue. 15. Yeah. Uh, this is high. It's supposed to go to low. Wait, hold on a second. This didn't work. Oh, no. I'm looking at the wrong thing. I'm looking at the wrong thing. And then we just unpack the low anyway. Wait, but... Oh, we add 0. So it should be... Okay, so we're not even looking at the high. Ignore the high. It's just the low because we unpack low into res. And that's why this is... $2856, $155. $2856 should be the 0 technically, and then this should be 155 if we did it correctly. 155. Yeah, I think actually this is missing a step. Yeah, I think this is missing a step because we need to actually add 155 and 15. I think. So if we add this, it needs to go into one value, not 2. Yeah, it ends up as 116 and 37. But the 37 just gets unpacked to here. Yeah, it looks like they don't actually have what I want here. Don't want to confuse you, but would it not make everything easier since it will all be filled? Are you talking about this? Yeah, that would be nice, but I don't actually have the 256 header is the problem. That's why I'm doing it this way. Oh, but you're talking about uh maybe that would make sense. You're probably right there. So you would say, oh, wait a second. Yeah, this already loads in 4. Yeah, that makes sense. That does make sense. Yeah, we can do it like that in a sec though. I kind of want to get this working first. So do you see the issue though that I'm running into here? Is I need 0 and 1 to be added together. And we don't have H sub or H add, so I can't do it. You're not saying that? It might make everything easier if we used all the space. My Truman Show talking. Is the birthday party that boring that that this is more interesting? Neural, do you know a way to do this though? A way to add register index 1 to 2? Because I'm not seeing anything that does that. Unless I would probably have to shuffle again. Which, well, no, but I see the issue you have. Yeah, you see the issue. You see the issue. Yeah, I probably have to like, I would, gosh, this is getting so complicated though. Okay, so I have to shuffle again. We have to shuffle again. And we know how well that went last time. That is why I thought if we moved 2 at a time, we could have loaded 4. Nah, but in that case, you're always going to end with 2. Because our sub, right? Our sub... Wait, hold on a second. Am I stupid? No, yeah. Wait. Am I... Wait, am I stupid or something? Wait a second. If we move... Wait. Okay, wait, I might just be stupid. I think I'm just, like, overcomplicating things here. So let's just walk through it again. I think we already have the answer. I think that I'm just freaking out for no reason. Because BM and I high, we only need the, in BM, for example, BM does the multiplication, right? So this times this times this times this. And then they store them separately. All we have to do is add them together. Oh, so BM actually, so okay. So it's, we need to add this and this. Oh, I did this wrong. Okay. Okay, so in this case it is, it's 501 and 49. And all I did was I just copied it down into the lower register. Alright, Hamish. Alright, man. Alright, man. Alright, man. Okay, so I need to shuffle then. There's no way to get around it. I just need a shuffle. Yeah. Okay. So um we don't need to even move HL is the thing. We just need to do another shuffle. The problem is I don't want to go through all the bit mask bullshit that we had to go through last time. All we need to actually do though is to get the top to the bottom. Is to get the top bit to the bottom bit. So we already know that this swaps the that and that, right? The top and the bottom. I just need to get the top to the bottom. If I had to guess what that would be like, it would probably be this or this. I can't really figure it out, but I think we can start with that, and then yeah. So this is gonna be BM. Or we should be doing AM first, and then we should just step through this. I really did not think that this was going to be so insanely difficult. Okay, so here we're only looking at the bottom, but this kind of sucks because wait, hold on a second. 16-0. Oh yeah, this is a sucky this is a sucky example because we just have 0 in the imaginary, so it's like we don't even have any like basis to go off of, but we can check anyway. Yeah, that actually hold on. We just need to get 0 in the first position. So actually it's the same exact shuffle that we already did. Yeah, because they're parallel. So in that case, we can do this like this. And this is going to be the exact same for the imaginary. Okay, I think that this works. I wish that we could get a good example though. Okay, so here we need to subtract. Okay, well that's just 0, 0. Unless BM ends up in the high word, which I don't think it does. Zero 9. Yeah, so that just ends up as 0 in this case. Okay, so we're adding BM is 0, -10. So we need to get -10 to where 0 is. And we end up getting -17 there. How? How? Wait, how does that bit mask work there but not down here? 0, -10. -17, -0. My mind is gonna blow up. That's what I'm saying. Like how does this bit mask do the bits properly here but not here? It makes no sense. It actually makes no fucking sense. Like why? How does this get? It's the same thing. I'm gonna assume that this is wrong too. -108, 74. We want 0 where the 108 is. And we do end up with it here. In the formula, we do real times real minus imaginary times imaginary. Yes. Yes, and then we do real times imaginary plus real times imaginary. Wait, but so this actually works. So this actually works here, but it doesn't work here. The shuffle does not work here. Am I crazy or what? Are you watching this? Like, that makes no fucking sense. Oh man, that's insane. That is crazy. I really hope that you're able to breakpoint through this and we just haven't been like going through nonsense just because you're not allowed to like check the registers by breakpointing. I hope that that's not the problem. Because that would fucking suck, man. That would suck, dude. That would suck. Yeah, I don't really know. And I'm gonna guess that IAD is incorrect. It's supposed to be in this case it's supposed to be 0 minus -10 or 0 plus, or yeah, so it's supposed to be -10 and it's -17 because of the shuffle. Yeah, I don't even know what to do is the thing. I don't know what to do. It's the problem. This shit is so fucking stupid. Which we could get a real in a single register. Yeah, it's hard. It's hard because we need to shuffle it every time. So here BM is, well, it's 0, 0, so that's not a good example. Okay, so here BM is 0, negative 14, okay? And this somehow becomes negative 116. So this is 0, 0, 0, negative 4. Okay, so there we go. 0, negative 4. 0, negative 4. Okay, so we swapped it here. I mean, I don't really know. Listen, I'm whatever. Okay. Now how do I actually like figure out if this is correct? Should we like get this out on paper and do the equation or what? Negative 53 and negative 5. And this is 0.9 and nothing in the imaginary. Okay. So we start with the multiplication. So it's just the bottom two. 53, 5 times 0 times 0, 0 times 1, 0. So it should just be negative 53, right? And so we get BR. BR is, oh no, AM. AM is negative 50. Oh yeah, that's fine because it's 0.94. Okay, so BR is 0. Yeah, so this is swapped once again, and now we come down here, A0 times BR, which is 0.5 or 53 times 0, so that's correct, and then negative 5 times that, and so that's correct. Okay, so that is both of the multiplications, right? Okay, makes sense. And then we swap AM, which is negative 50, 0, so 0, negative 50, and then we subtract them so that we end up with negative 50, right? Because it's negative 50 minus 0. Okay, so that's the same thing. Now we also need to shuffle BM, which goes negative 4, 0, and then we add them together, BM and ILO. Yeah, I think that since there's 0, it's a bit confusing, but it's basically how it's supposed to be, right? And so we end up with negative 4 and negative 50, and so we get negative 50, negative 4. Exactly. Because this should always be in the imaginary, and so the top gets that. And so it's going to go upwards. The issue that I'm automatically seeing is that I'm really worried that this is going to go out of bounds because there's 4 in this register, and it may end up at the end of the array. So there is that, which does worry me. But I think for now, all we can really do is just call the function and go for it. Just fucking send it, you know? And we did it. I think we did it. I hope we did it. It seems like we did it. Cool. Now we're 1% faster. I don't know why, you know, I got sidetracked on it. It does look fine. Yeah, it might be slightly off somehow. I'm not sure. I hope it's fine. It looks a little bit different. I'm worried that we did something wrong, but I really don't know how to check. We could try comparing it side by side, really. That's what I'm gonna do next. Yeah, it's definitely different. Without a doubt. Yeah. So I think we messed up somewhere. So, yeah. Yeah, so that's cursed. I mean, yeah. I tried my best, but my best is not good enough, unfortunately. I guess it's possible that, like, yeah. Yeah. I wish I knew about this better, but yeah. Okay, well, I tried my best. Now I'll just go, you know, go to do what I was supposed to be doing today, which is the 4-panel display. Yeah, that does kind of bum me out, but it is what it is. Okay, so 4-panel display. What do I mean by 4-panel display? In my 2D implementation, I had this, they have it as well in their implementation, is that you have 4 different views of the same grid, right? You have one that's the regular simulation, you have one that's the weighted neighbor sums, and you have one that is the growth. And so that's what I'm going to do now. So this is actually going to be a lot simpler than you would think. Basically, all we need to do is do this 3 times within the same loop. We're going to be in the same exact grid space as we are for everything else. All we need to actually do is do different marching cube calculations for each view. And so we need to do this 3 times, right? So I think I'll just make it. Take care. All right, peace out. Good night. Thanks for the help. I'm sorry that we did not get it. I'm just going to call this cube data. This is marching cubes. And so we'll just put literally all of that in it, and we'll just have it to the amount of views that we have. Yeah. I don't think that we can loop through them though. Or maybe we can. No, we can't. It's just good to have it neat, right? We're only gonna have 3 because the kernel is going to be the last one, and the kernel we have to do separately because we don't actually have it in 3D space technically. So we have to like translate it and shit. Or maybe we can do it like this, but yeah. Let's for now, let's just start with this. Okay. Okay, so everything has to, you know, be into that. And so yeah, so let's do I'm trying to think if I really want to make an enum for this or what, but yeah, sure. We're gonna call this U, view G, view kernel. Okay, now those are the views. So that's what we will store it in. So okay. So we need to do this per view. Okay, so I know. I get it. It's an array. You can just loop it, but we can't actually because of the different arrays with the different layouts. Okay, I know. It sucks. It sucks. Trust me. I know. I'm well aware. I'm probably more aware than you are that it sucks. Okay, but it has to be this way, or else I'm going to lose my goddamn mind. You. Yeah. Okay. The tricky part is that I need to offset all of these, offset these by their own offsets. Yeah, I need to offset all of these by their own offsets. Really smart, dummy. You're really smart. So is this val fine? So how do I get this val? Val is okay. So this is also actually on cube. Data view cells dot val. This is the same thing. It's just a bit mask that we're adding on to. Damn. I feel like we were close. Like it looked good. Like, you know, it looked like it worked. It's a bummer though. Whatever. So this whole verts thing also needs to be per thingy. The interpolate edge, by the way, also. Oh no. This goes, yeah. So that's fine. It needs to happen separately though. It needs to happen separately. Oh, this is in the same file. Okay, yeah, it needs to happen separately for each of them, which also sucks. Okay, this part we can do per view. Yeah. Edge table for the val, right? Yeah. V count we don't actually even use. Okay, so let's just go. We're just gonna hard code it. Okay, so that's our index into there. Now we have to just get the verts. Yeah. Okay, all of that is good. The points, of course, are also has to be from here. And the vowels and etc. We can make this faster later. I just want to, you know, get it working and structured. Okay. So now comes the actual hard part. I think we just wrap this in a for and call it a day. I think that's what we do. I know that it's ugly, but it just kind of makes sense. It works out that way, where we can just loop through the amount of views. The tricky thing is that each one is going to need an offset, and that's the awkward thing. So we could have an int of an array of offsets that do the thing. That do the thing, yeah. You know, do the thing. Okay. Okay. Okay, I think that this is good. Tricky thing is now that we have to offset the points. We either offset them here or we offset them beforehand. I feel like it's faster to offset them beforehand because if you offset them beforehand, then these duplicate sometimes. They duplicate the same vertex, so you need to offset them beforehand. Okay, cool. So let's just make an array of vec3 offsets for each view, and then obviously the 0 is going to be no offset, and then the offsets for 1. Okay, so let's think about this. Where are we starting origin wise? We start at negative grid half actually, and then we go to grid half. And so we should really, I think we just really, for the first one, we can just straight up add grid width. Yeah, add grid width to it, and then for the second one we can add it in the Z direction. And then we just have to vec3 add for each point. Oh, wait, this is I. Whoops. Whoops, 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 whoops. Okay, so that's done. Okay, I don't know if this is gonna work, but I hope it will. Oh shit. Okay, well thank God it didn't work because we didn't actually make the buffer bigger. We just didn't do that. What? Only static const integral data members can be initialized within a class? What are we? What? Oh, oh my bad. I was like, what? That's such a weird way of saying that. I was like, what? We do have to initialize it here, though. Yeah. Okay, so we have to resize the buffer before we actually press compile, or else we're gonna like break the computer. So obviously this is going to just be ×3, right? Like we don't have to think about this too hard, it's just ×3. Right? The explanations of the errors are completely useless, yeah. Exactly. All I care about is the line that tells me where it got mad at me. Okay, we gotta get rid of this shit. Okay, so this has to be ×3 because of the B offset that tells us where we live in the array. I hope that we don't run out of memory. It's actually a possibility with DirectX, but we're gonna pray. Okay, it's still mad at me somehow. Vval. Oh. Oh. Yeah. Okay. Points, undeclared identifier. Oh right, yeah, I have to do this actually. It's kind of janky, I know. What? Subscript requires array or pointer type. But this? No. Like this. Like, what? That's exactly what I had. Wait, what? Dude, Oh, wait a second. Oh, wait a second. G doesn't have a zero there. Cannot FFTW complex to float. Wait. Oh, this is this is the index by kernel. Oh shit. Okay, then just do H. Just do H. Just do H. I just do cells H. Yeah. Okay, so we aren't doing the weighted neighbor sums because that would be too expensive, at least for right now. Oh, this is into 0. Okay. Ah, shit. You know how I said that thing about we're gonna run out of space? You know how I said that thing? Okay. I got rid of the headroom. Okay. Okay. I'm not sure where the other one is, though. I'm assuming that's the growth, but it's not really coming up as much. Oh my gosh. With the higher ISO value, it kind of pops up a little bit more. The frame rate has definitely suffered because of it. That is for sure. The good thing about the kernel, though, is that when we draw the kernel specifically, it doesn't need to be updated all the time because the kernel isn't changing. So there's at least that. Max channels also shouldn't be 6. Max channels we can put to 3 or 4. Should put it to 4. There's no need for it to be higher because we're never going to be able to get past 4 on this hardware, so it's pointless. Okay. So let's figure out why that other array isn't working. I have a feeling that I reused the H buffer for something else, and so that's why it doesn't work. That's what I feel like. It's also possible that the H is supposed to be... Oh, wait a second. Isn't the H per channel? Yeah, it is. So I'm... Huh. Oh, H just equals the G. So they're exactly the same. I wonder how I did this before. I think what I did was I rendered all of the U's on top of each other or something like that. Yeah, that shows the kernels, then the H, then the U, and the G. Oh, that's just the grid. So the grid's the U and the G. But the U is per kernel, right? I have it per channel. How do I have it per channel? The U is per kernel. Maybe I just always did this wrong then. Because I index it by channel. I'm looking at my other code base, by the way. I index it by channel, but I use it per kernel. And inside I index it per kernel in here. So I always was doing it wrong. Okay. Well, then there's multiple ways of going about it. I could just sum U into another buffer, which would be a little bit more expensive. Or do something else, I guess. I don't know. What would be interesting to visualize? We can like literally put any buffer in there that we want. What would be interesting? We could try visualizing F, or yeah, it would have to be F because we don't have MUR in a buffer anymore. It would have to be F. We could see F. I mean, why not? We can just like literally put anything in here. Isn't it just... Oh, the problem is that F is a vec3. So, yeah. You know what might be interesting actually? If we use F for normals, because F is basically the mass vector in terms of movement. So that might be interesting, actually. That might be interesting, but, you know, yeah. You can't really do it. Yeah, I think what you want to do is you want to sum the weighted neighbor sums into one buffer, but it's definitely, it's gonna kill the cache that we just work so hard to optimize, so there's that. So we need a buffer called like usum. Okay, let's make it, I guess. Okay, where is this? I'm like scrolling trying to find the code for this, but it's here. It's here. It's just hidden. I wonder, yeah, you want to divide it by U size. So, yeah. I wonder if you want to put it in the same layout because of the memory, because of the whole cache thing. You probably don't. You want to transpose it into the other layout, so that's what I'll do. I think either way you're kind of hurting because of the cache, so I think this is kind of the best way to do it. Yeah, so use sum to max channels, and we'll just sum it. We have to do cell fft c dot u k I 0 divide by grid size. You do this out here. And then you just sum it. Inside of here, cells I dot usum c. We have to mem set it too, which isn't great. The problem actually with this mem setting the usum thing is that I hate when we have to mem set this stuff that's with this memory layout because we can't actually do it. We have to actually loop through and do it by hand, which sucks. So the cache is happy, but we're not happy. Does that make sense? We are not happy. Is this... Okay, so now we have the usum. Wow, I did not expect to compile. I wonder, so something is preventing us from getting more than one view. Oh, fuck. I'm so dumb. Oh my god. My bad. Let's rendering them on top of each other. That's pretty fucking cool. So, by the way, what we're looking at right now are 3 different steps of the equation. I wonder if the U sum, we have to normalize it by the amount of kernels, and that's kind of, you know, that's kind of what worries me about the whole thing. I'm just not sure if we're doing it correctly. Also don't know which is which. Hey, what's up, Jess? Yeah, I think without ISO value high, you don't really see anything going on with the other views. Okay, so something that I'm thinking about here is that the U sum that we're doing, this U sum, I don't think we ever go into the correct channel, or do we? C. I guess we do go into the correct channel. How do we get C? Oh yeah, so we do go into the correct channel. So that is that. I think that that's just like, I think we did it properly and everything just kind of works, but yeah. I guess so there's a couple of things that we can do here. We can transform the kernel into the center of the grid space and then have that be our 4th panel. I also am interested in the idea of using F as the normal, but I feel like it would be kind of difficult to do. because you would have to transform each of these points into grid space. So I have this function called grid index, but I don't think that that's going to work necessarily, because we already offset these, obviously. So our transform into grid space isn't actually going to work. So to do this, I would want to try it out with just the main panel first, and transform it into grid space, get the vec3, and then put it as the normal. So let's try it. So vec3 p0n equals the cells c, cells I. No, it's not cells I. It's cells, oh right, that's what I'm trying to get. So cells grid index of the p0. I don't know if it's going to transform correctly. I forget what the function does. And then this is the channel. So that's that. And then we just... I always had vec3. I need to put this into a normalized function. And then we can test if that makes this... if this works. I don't know. It's a pretty obtuse way of going about it. But it's worth a shot. Okay, so this is going to be P0N, P1N. I had it this whole time. Yeah, I made an entire game engine and a math library for the game engine. I always had a vec3. Interesting. Interesting. It's kind of cool. It is kind of cool. The normals aren't necessary. Then why am I dipping into simmed intrinsics? Because I want speed. It is neat. On the border it is a bit weird, but I think that's just because F on the border, because of the border style, is weird. It's actually pretty incredible that F kind of just works as normals. But I don't know if I like it necessarily. It does kind of make everything just kind of meh in terms of the lighting. It does surprisingly make smooth shading though. Kind of smooth. Now I kind of wonder what MUR would look like, but, you know, getting MUR out as a buffer would be incredibly inefficient, so I'm not even going to bother doing it. I'm not even going to bother doing it. Yeah. Not even gonna bother doing it. We can figure out smooth normals next, but yeah, so that it was good to at least try it. Yeah, I think that's kind of. We could also try magnitude of f. Could be interesting to see in a thing. We do a transpose here for h, which makes sense. I think that this still is absolutely just makes sense. The thing is, actually, this g doesn't ever need to be in this order. In fact, we could just like sum it into straight into h in grid major order and avoid the transposition completely. I don't really think that it would be like incredibly fast, but it is possible. H and G are equivalent, so hey bro. Hey, what's up, Marco? I'm working on a cellular simulation. It's a simulation that has been run, it was created a few years ago, and it's been run in 2D, and I wanted to make it in 3D, and so that's what I've been working on lately. I'm indexing that correct, yes I am. Okay, so instead, so we avoid this instruction here by doing that, and we can just use this instead. And now we'll never use G, we'll just use H during the render loop. Those should be completely equivalent. I wonder if we have to, I assume that we have to clear that out though. And we actually have to do it this way. .h, yeah. So get rid of that. Okay. Starting out in the world of programming out of nowhere, YouTube recommended the video to me. So learning some web development. C++, yeah. I love C and C++. That's what I do. That is what I do. That's sick though. I do think that that C++ is, or C and C++ are languages that every programmer should know. So yeah, this helps us out a lot actually in terms of cache. Okay, yeah. So this as well. And now I believe we can swap the do I program video games, or is my work more related to creating drivers? I don't really know that much about creating drivers, to be honest. I want to do more bare metal stuff, but I am not known for that. I don't really make games. I kind of just like make interesting projects, or things that I find interesting, at least. Oh, did I get rid of the offsets? But why are they rendering on top of each other now? What did I do? Ah, there we go. Yeah, that's what I did. Okay, so I mean, it works-ish, I think. I mean, it works, but it's kind of mesmerizing, some of the stuff, you know. Wow, that's kind of cool. Looks like a face that's being reborn, yeah. So there's two things that we could do next. We could try getting the normals to be smooth again, or we could do the kernel. We could do the kernel. The thing with the kernel is it's going to be kind of annoying because we basically have to just like do marching cubes, but in a separate loop when we create the kernel. Initialize a new kernel. We're just going to do that. Did I learn C++ straight away, or did I start with C? I don't really use C++, to be honest. I don't really see that much of a need for it. I think it's probably good in, like, you know, if you're working for some sort of company or whatever. But I think I just use C pretty much, you know. I compile C++ when necessary, and I know what some of the, you know, the basic features of C++, but I don't know. I just prefer writing C straight up. I don't like std vector. I don't like any of that shit, to be honest. I don't trust any of it. That's pretty sick. What's good about C sharp? Or was that supposed to be a question mark? What's good about C or C sharp? C sharp? I don't really know anything about. I don't really know anything about C sharp. Couldn't say. How many years have I been programming? I started when I was 16, but I haven't been programming for all those years. Just off and on. Yeah, that's pretty cool. It'll eventually stabilize back into the same pattern that we saw earlier. Like that. I'm a capo? Like the thing that you put on your guitar? Genio de genius? Does that mean I'm a genius? I don't think so. I just spend a lot of fucking time in this room coding. Nothing that special about it. I remember the guy from MMO forums. That guy reversed the package structure protocols and coded an emulator. Oh, that's pretty cool. Do I know any words in Spanish? No, but my mom is Puerto Rican. But I don't know any Spanish, I'm sorry. Yeah, So, I think it would be pretty slow if we translate the kernels into real space and then drew the kernels every frame, but it might be interesting. I wonder like what we could do with that if we had kernels per frame. Kernels per frame. What would that enable us to do? I don't think we would be able to do much. I'm trying to figure out if I want to just pre-compute the render buffer for the kernels, or if we want to do it per frame. I'm trying to think like what would that enable us to do with doing it per frame. It would be more expensive for sure, but would it be more interesting? Maybe. What would it enable us to do? I'm trying to think like what would we modulate the kernel with? Maybe it's not worth it. It's not worth it. The problem is if we don't do it per frame, then it's going to be painful. Every time we initialize a new kernel, we either would have to rebuild, we would have to rebuild the mesh. We'd have to rebuild the mesh here. What branch of programming do I work in? I don't work professionally as a programmer. Do I think I could? Yeah. But, like, I don't know. I'd have to read, like, a systems programming book. I guess I'm a hobby programmer, yeah. I don't know. I treat it like a fucking job, though. I either have to transform this into the other way, or I just like, okay, so that's what I'll do. I'll just make another buffer. It's fine. I'll just make another buffer. Yeah, so this is just gonna be, I had this in my last implementation. It's just real K, and this is just gonna be the real, it's centered in grid space. How do I do that though? This centers it at 0, 0, and it wraps around, right? What is Rx, Ry, and Rz? This is offset width, which is this. So it starts in the negative. It goes to positive half. So I feel like I could just get away with adding offset width to Rx, Ry, and Rz and just using that instead. Like if I think that this works. So K, real K. Rx plus Yeah, plus offset width plus ry plus offset height times, yeah. Okay, there. We also have to normalize it here. Okay, we also have to mem set it. And when we initialize a new kernel, all I'm going to do is I'm just going to rebuild the mesh from scratch. So we have to implement that as well. And let's just put this in render just because it's a render thing. I'm not really sure if we need to thread this right now. It's not really necessary. Here's a question we have to ask. Are we just literally going to do the same thing as this? Because if so, we can probably just do it in this function. No, I don't think that we can. Because we want to make it hollowed out. Yeah. Yeah, we're going to iterate it differently. Because we don't want one quadrant of the grid. Right now, the sphere is inside of the center of the grid. And so we want to actually take out a quarter of the grid so that we can see inside of it. That's basically what we're trying to do. Okay, so how do we do that? Well, first of all, we need to make a new mesh buffer. We don't need a front and a back buffer. At least just to be simple right now, we don't. It's not necessary. We can just create one buffer like this. And it's just going to be like this. Max channels is going to be max kernels. Yeah, I think so. Yep. And we will put into here a new buffer that we are going to call kernel verts. Okay, that's what we're calling it because I decided on that name right now. Okay. Okay, really, we don't need it to be a dynamic buffer necessarily, but for now, let's not worry about it. Because that might just like cause other issues and shit, and we just don't want to worry about that right now. Okay. So now that we have that as a global, we're just going to lock it and then rebuild the kernel mesh. So the thing is, we're going to be doing the same thing as here, pretty much, except we're going to be going per kernel. But I think we're also going to do marching cubes. It just kind of makes the most sense. But yeah. Yeah, let's not worry about the max threads for now. We are going to need the delta. And we are going to need this to offset the points. And we will just keep a vec3 offsets for the whole thing, which will be it's going to live in that quadrant. Okay. So we want to loop for each kernel, I think. Do we want to do that on the outside or not? I don't know. Okay, so let's just, it's going to seem like I'm copying a lot of code here because I am, but I'm just going to like literally like just get rid of half of it. I just am going to need some of it, right? So we don't need cube data, or we can just have one cube data. Once again, we're cutting a quadrant out. Yeah, that's a bit difficult to do with this, to be honest. I'm just gonna have to do it within here, I think. I'm gonna have to compute that. Yeah. I'll think about that while I'm doing this, but yeah, I'm gonna have to compute that later. I don't think this mid-val is getting used at all. Once again, we don't have to do this. This is going to be just cube data. We can get rid of all of the arrays. It's going to be kernels k dot real k that we just did by the grid index. Yeah, that's what we're doing. Okay. We want to assign a different color to each kernel, I think. So that's what we're gonna do. Okay. Okay, so this V is just, we can write straight into, for now we can write straight into what did it, kernel verts, and we'll just have a global count for now. And we'll just make that a global. Okay. Okay, I think that I did it correctly. The thing is the color, right? Let's make an array to max const d3dx color colors to max kernels. I don't even know what max kernels is. 12. So we can just like make a bunch of colors that are just like random. D3dx color is actually just like I think that we can just do this, right? So this will just index into this to get the current color to draw with. Okay, so this will be that, this will be that, this will be that, this will be that, 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 and the rest we don't really care about for now. So let's do yeah, so that will be the color that we draw with. Okay, now I just have to put this in the header and then link it to the kernel call. So every time we make a new kernel, we will make a new buffer. Yeah. Thing is, though, we really don't want to call that from the kernel, or maybe we do. It's kind of gnarly to do that, to just be like, you know, rebuild kernel mesh here, because we have to lock it and all that. But maybe for now it's just pretty simple for us to just go ahead and try to do that. So we're gonna do the same lock and discard thing here, same pattern but without threading. We're just gonna call this on kernel verts, and we need a block here because we don't have a back buffer, but that's fine. Now I'm not sure. Actually, pretty interesting here is that this is actually going out of bounds. This is supposed to be 15. No. Okay. Okay. So we want to rebuild kernel verts. I called it built kernel mesh. And unlock it. And that's just that. I think so. I think that's it. That's exactly what we have to do. And we also, in here, we want to zero out kernel vidx every time. It's kernel vcount, is it? Yes, it is. My bad. The other thing uses vidx, so that's why I was confused. Okay. Okay. So when we render, what I need to do is just render it afterwards. We're just going to set the stream source, and that's it. Set stream source kernel verts. And we will just draw a primitive to kernel vcount from 0 as the offset. Now, the final part of this is that I need to hollow it out, right? And so it would be really easy to just do like a this, but I kind of want it to be like a 1/4 of it, which of course becomes a little bit more difficult. There's probably like a really neat, easy way to do it, but I'm too dumb. So let's think about it. Really what we can do is like if our gx is greater than or equal to grid width divided by 2, then we want to yeah. No, I'm being so dumb. I'm being so dumb. It's just literally that simple. And if I did all of this correctly, which I doubt I did, should be fine. So we have 27 arrows, which I'm not surprised. No overloaded function takes... Oh, you're being a jerk. You have the jerk disease. I see. It's because I didn't do the constructor for a D3D color, which is my bad, I guess. Okay, so why? Oh. Oh, right, we need to start. These start. Okay, start X and start Y, by the way, are negative. It's this. If we're doing it from scratch. Yeah. Okay. Let's see. We have 12 now. Oh, yeah. Code. Code, 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 code. Code. Wait, what? Oh. White theme is ass. Okay. Interesting. Got some very interesting people lately in here. Jesus. I don't know, man. Like, fucking bizarre, man. Like, dude, like, it's just so weird. It's just so fucking weird. I think it's like my chest engine video just got like the algorithm or whatever, and it's like just fucking weird. Yeah, that's okay. I do allocate this. I really hope that I'm not out of memory. I might be. Oh no, we initialize our kernels beforehand. Why? Is it necessary for us to? I'm not sure. I don't think it is, so I'm just gonna do it afterwards. Yeah, let's just do it here and then see. Okay. Okay, so we're not drawing anything. There are some really big issues in terms of the, I think it's just all over the place, the kernel. I think it's like all over the grid. Let me try getting rid of this. We do add the offset here, so and the offset, where's the offset? Yeah, the offset is correct. Yeah, so that weirdness happening inside, I think that's due to the kernel mesh. Yeah. For some reason it's being very strange. Window close button not working. Yeah, I have to fix it. Something is making it not work. It's probably just like I need to like look at the thing again, but yeah, I just wanted to get this working first. We can step through it, I guess. It's like the only thing I can think to do. I also wonder, like, I'm not going out of bounds here, which to me like means that I probably did it correct. That is actually supposed to be offset height. I'm correct there. Oh, shit, yeah, I don't know. I was kind of expecting it to just kind of work, but maybe I'm just stupid for expecting that to just kind of work. Let's see. Okay, let's see. Okay, so let's I guess see what our V count is and see if we're actually drawing anything. Also, maybe we have to set stream source to 1. Kernel V count is 0. Okay. Okay. So, kernel V count is 0. Okay. I'm not entirely sure why. But let's go check why. But why? Oh, it's because I'm in release, that's why. It still is 0. Like release mode wouldn't change that. Okay, well, we aren't getting inside the inner loop. Oh. Yeah, we aren't getting inside the inner loop. You know, I should have checked this if we're getting up here. Okay. We get here. Okay, so val is 0. This val just never gets anything in it, I think. I wish that I... Okay. Yeah, I mean, it's... Okay, so the kernel is kind of small, right? Like, the kernel is in the center, you know? So, it does kind of make sense. But it's also like... Okay, so let's just put a breakpoint here and stop being annoying. Because this will show us... So yeah, we are getting values. We are. See, we are. It's just they're right inside of the middle, right? And so I'm really interested to see... I want to know what this is. RZ1, RY0, RX negative 3. Negative 3 plus 16... 0 plus 16, RZ plus 16. Yeah, so this is the center, because these are basically at 0. So I did this correct. This is absolutely correct. But it's not building the mesh. So probably we're stepping through it and trying to debug it, but I mean, it's just going to be the center that matters. So that kind of makes it hard to debug what's actually happening here. LC equals color, which is fine. The color has an alpha of 1, so that has to be fine. But kernel v count is just 0. It never gets in. Never gets in. How about let's try this. So it might be the ISO value, actually. It might be the ISO value. Let's do like something like really low. Okay, I still don't see anything, but let's put a breakpoint, I guess, and see if we get in now. Let's actually drop a breakpoint down there. Or no, let's just do this. Let's just press the R button and see. No. We do not hit the breakpoint. With an ISO value of that low, we still don't hit the breakpoint. It should be in the same coordinate space. Unless our start and shit is. Oh, wait a second. I didn't copy the code correctly. We don't actually step through the grid at all. Oh my god, that's so dumb of me. That is so fucking stupid. Yeah. I need to match up the... Yeah. Why did I do it this way? Because of the complicated indexing for the fucking... for the other loop is the reason why I did it this way. So you may be like, why would you even do it that way? But it's like, yeah, I did it that way for a reason for the other loop. If that's not the bug, then I'm gonna be pissed. The fuck are we talking about? Okay, let's make sure that this is the correct... No, this is not the correct... No, I'm... Hey Max, it's going good. You know, some odd fellas in chat for sure today, but no harm. No harm at all. The code is good. I think we've learned about simmed instructions today. Really, like the whole 9 yards. Okay, but this shit is gonna make me lose it. This shit is gonna make me lose my goddamn mind. Like, there's gotta be something fucking stupid that I'm doing. There has got to be something fucking stupid that I'm doing. Bro, close the... Okay. I wish that I could figure out the nested thing. There is a reason nobody did this before. Yeah, there's a good reason people haven't done a lot of things before, like fucking being lame, for example. A lot of people are lame. So true. I'm computing this correctly. Like, this is... Yes. Okay, let's calm down and let's look through the other code. Okay, let's also put this back to a not crazy ISO value, like an ISO value of 3. That's also good. What would be fucked up is if this was... So we aren't getting anything because our cube val is always 0. So we don't actually get through here, do we? We're never gonna trip it. Yeah, we don't trip the breakpoint, brother. Okay. Let's lock in. Okay, so we do this the same. This mid-val does not matter, right? Mid-val does not matter. Yeah, that's the only reference, bro. Yo, what's up, Absolute? Okay, we do the exact same thing. We do the exact same thing. So true. Then we do that. Yeah, absolutely makes sense. Did I miss you? Considering the lovely experience that we've been having with certain individuals today, yes. Yes, indeed. Yeah, we have to be interpolating by the same ISO value as here. That's important. Yeah, our val just is never not 0. There's gotta be something stupid that I'm missing. What do you mean, why though? Me? Me, why? Why? I don't know, bro. Okay. I mean, like, seriously? We're just gonna... Why is the val never not 0? Yeah. You're telling me, bro. Wait a second. Hold on. What? Hold on. Okay, no. It's 3, bro. It's 3. Don't freak out. Okay, now the val is always going to be 0. We know this for sure. We know that. Because we need to know where we're in the grid. Opinion on the new iron lung? Yeah, I've heard about Markiplier, bro. It's crazy. I was never really a Markiplier guy, you know? Or like a PewDiePie kid, you know? But I respect it. Okay, we just need to check if this value ever goes over here. Yeah, can this just be the breakpoint? Right here. I just want to see this. Pectorals? I do not know about Markiplier's pectorals. Dude, I would love it if we could get the breakpoint over there, my friend. Like, you gotta be fucking kidding me. Okay, Rob. I'm with you 100%. I've never done anything this stupid before because usually I can just printf, okay? But we're just gonna do this. Because, okay, we can't actually use X. We're gonna call it Rob. We're gonna call it Rob. Shut the fuck up. Okay, that's the wrong breakpoint. That's the wrong breakpoint. Nah, give me the breakpoint, man. Oh my god. What type would Rob be? An integer. And he's set to 1. Bro. I mean, seriously. So, okay, so let's see this first before we start freaking out. I mean, what is fucking happening? Okay, we got into Rob. Okay, let me see the value, you fucking freak. Bro. I'm gonna crash out, I'm gonna crash out, I'm gonna crash out, I'm gonna crash out. Brother. I need the fucking value inside of real K, or I'm gonna fucking lose my mind. It's actually crazy that it doesn't tell you. It's actually fucking a crime. It's literally criminal. Oh wait, we can go into here, we can go into here. It's 5. This shit is great. Wait. Are you reading the fucking code that I'm reading right now, dude? Are you reading the code that I'm reading? Let's walk through it, okay? This value is 5. It's greater than the ISO value of 0.5. It's not 5. Oh my god. It's that tiny? Oh, that's an E. Oh my god. Bro, how small is that value, dude? Okay. Okay. We're gonna go 0.005 and just play ball. Okay, but motherfucker, how small does it have to be? Are you fucking kidding me? What? 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 What am I trying to fix? I'm trying to fix my brain. Okay, so listen. This is how marching cubes works, okay? So we have a scalar value, okay? And we're trying to find if it's bigger than this constant, okay? However, for whatever reason, my kernels are like 0.000, like insanely small. And I did not think that they were that small. I'm gonna keep it real with you. Okay, listen. Okay, we got some stuff in there. We did it. Okay, now render the goddamn kernel. Are you changing the value somehow? No. No, it's just very small. The kernel is what the entire simulation runs off of, so if the kernel was bad, then the So only, yeah, exactly. I need to have like ISO values that are like kind of in the middle. So I could just like take the mean or whatever. Actually, yeah, that's what I should do. It's kind of hard though. Okay, so the funny thing is that we're not rendering fucking anything still. So that's like really cool and all, but like, can we render something? Like, we are actually getting vertices in there. We're just not rendering anything. What if, right, you take the kernel values and then multiply them by something less than 1 and bigger than 0. Okay, that would make them tinier. That would make them tinier. Okay, so we're getting vertices in here. Let's see the points. Okay. Yeah, the points are correct, brother. The points are correct. Let me tell you, the points are correct. The points are correct and we're still not drawing. Okay. Okay. This shit is so dumb, it's turning me into fucking Squidward right now. Okay, put it to 0. Yeah. Okay, let's do the breakpoint here and see what the kernel v count is. It's 0 because for some reason it doesn't do it on init. I don't know why that is. Don't ask me. But once we press R, okay, it's not gonna let me press R unless I get rid of the fucking breakpoint. And put that value in the ISO. That's true. That is true. But that is kind of like cheating. Okay, stop, please. Please press the R button. Okay. Now press the R button. Oh my god, oh my god, oh my god, oh my god. You see that little fucking, sphere over there, brother? That's the kernel. That's the kernel. And I'm not talking about Linux. I'm not talking about Linux. That's the kernel, bro. Okay. It looks a lot less majestic than I thought. I'm gonna keep it real with you. Ultimately, listen, it is just a sphere. So I don't know what I was expecting. Okay, the reason why we're lagging, by the way, is because we're in debug mode. Don't like freak out about it and be like, "Oh my god, it's so unoptimized." No, it's 30 FPS, bro. But is it hollowed out? It's kind of hard to tell because I drew it black. Don't ask me why. Okay, it doesn't seem really hollowed out. What is a kernel? It's what we use for convolution. Okay, so we drew it. We drew it. Why does it not draw it on init, by the way? We init the kernels. We init the kernel. Oh, because we don't have kernel count here. We don't have kernel count here until the end. Alright. Kernel count ++. There we go. Higher res kernels for the simulation. They are already like really high res. So it's just that they're small. We can go into release mode and then see. I want to try a color that isn't fucking black, to be honest. A color that isn't black, and that will be the color of white because I want to see if it's hollowed out or not. I made you hollowed out. I did. I'm iterating you hollowed out. Oh no, I'm not. I got rid of that. Why did I spam? Because I make I made that for debugging purposes. It's not like really important code. That's code that just gets run once on initialization just to get a kernel that is interesting for the starting simulation. What, you want me to put it in a JSON? Is that what you want? You want me to put it in a JSON and then read it in? Pointless. Okay, yeah, that's fucked. Yeah, so this actually works. It's just because of backface culling, it makes the backfaces invisible. What you kind of want to do is you kind of want to connect these, right? But it's not easy to do that because they're on all separate layers. But basically what you're seeing here is 1, 2, 3, 4, which is the amount of kernels that we have, which they're like stacked on top of each other. So yeah, how do I connect them is the question. I could just also just like get rid of backface culling for just this mesh, but what I want to do is I want to connect it so that it looks like an actual slice. Hard to do that though, because they're all on different iterations, so I would have to probably have a pass afterwards that manually triangulates it, or yeah, I'm not really sure. Not easy, certainly not easy. For now, what I'm just going to do is I'm going to disable backface culling for that mesh. What is this, a project? Is this a game? No, it's a cellular simulation. Okay. Where is this? Oh, it's here. Oh, it's not here. It's here. I just have so much shit commented out there that it like trips me up every time I have to fucking scroll past it. I wish it was a game. Well, nothing is stopping you from making a game. Rob, follow your dreams. Okay. I think it's this. I wish that we were on the other side of it, to be honest. That would be really nice. And I wish that my move speed wasn't so fucking slow. I can change that. I'm in full control of changing that. Yeah, it looks like ass. It does look like ass, sir. Well, it actually doesn't look like ass. It only looks like ass because there's no fucking light over here because it's backwards. So what's strange is because of this is happening over here. Like the kernel mesh is over here. And over here. I think that that's because of the kernel mesh. That wasn't happening beforehand. Yeah. If I remove the kernel mesh, I'm pretty sure that bug will stop happening. Is it happening still? It might still be, actually. This flashing thing. I feel like that wasn't happening before. Yeah, this thing. It might actually be... I think that might actually be the... Yeah, that's not actually me, that's the problem. That's actually the buffer itself. I think, okay, so this is probably what it is. It's probably, there's persisting shit in the buffer that doesn't get cleared out. Yeah. There's persisting shit either inside of it can't be in here because we zero this out. Killing the evil kernel, yeah. We have to zero this out, and we do zero it out, and so it can't be that. So it has to be on the rendering side that there is some persisting stuff in there that that doesn't get cleaned up. Why might that be? Maybe it's B offsets that doesn't have enough room, or that our VIDX is off by some amount. We loop through here and then we loop through here. So there should be nothing incorrect there. Honestly, it might be like a syncing error between our threads. I kind of have a worry about that. Yeah, because we don't block the main thread for that, so it's possible. It's possible. I do memset it to, I do memset this grids, yeah. This is the correct size. And I do memset it to 0. Always. But there is persistent stuff in one of the buffers that doesn't get cleared. It's either that or the data is literally that volatile that it's flashing like that. Which I don't necessarily think it is. Our max definitely is 15 vertices a thing, right? It's definitely. Yeah, it is 15. Our max is 15. So then there's no way that we go over it, I think. Alright, peace out, Max. See ya. Good luck. I do feel like that wasn't happening earlier, but maybe I just wasn't watching, you know, enough. I could just straight up try not writing into the kernel just to make sure that it isn't that. Just like get rid of this. Yeah, sorry, I don't speak Russian. You see those like little, these like remaining little things there? translation what's going on here. I am working on a cellular simulation, but it looks like there are some parts of the draw buffer that are flashing, and so that's what I'm trying to fix right now. So for example, this, right? I think that this is a new thing. Yeah, this is definitely a new thing. I messed something up bad somewhere, and I have no clue where. When I was doing the other stuff. Are you sure this is happening because of the buffer? I don't think so. I think that when I was copying and doing some stuff here, I probably fucked something up. I can try just deleting this just to make sure that it's not some weird like driver thing. The interesting thing is that it doesn't happen from the starting simulation, I don't think. I don't think it happens from here, which probably clues us into something. Yeah. So this on the boundary is pretty interesting. How it's like seeping over into here. It's not supposed to do that, obviously. And now the data now persists. I know what it is. 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 That's okay, yeah, that was confusing me, but yeah, I know what it is. We need to zero not just to channels. We need to zero to max channels for these. Because if we swap the amount of channels and they aren't zeroed, then data persists. But it's still happening. I'm like 90% sure that it's something with that though. That we only set something to 0 based on the amount of channels. And we miss a channel or something. Somehow. It does kind of feel like though it's the draw buffer itself that's persisting. Like this used to be bigger. We had it bigger for a while. It seems to only be happening at the boundaries. It seems to be happening at the boundaries. Which probably means that we're iterating something wrong or something. Let's try this. No. Let's try it single threaded, I guess. Comment everything. No. We're not at that point. We're not at that point. I'm going to do it single threaded. That's what I'm going to do. Why not OpenGL? Because this is kind of like era accurate. I'm on Windows XP. Okay. Single threaded. Very slow. Is it working? It is working. That's exactly what I thought. So it is simply a threading issue, which is what I was saying. At the end we say is done. So that's the flag that once all of our threads are done, we say is done, and then we start again. Most games use DirectX 9 actually, like Splinter Cell, you know, a billion games in the era. Could it be that we're doing it twice? It could be. How am I going to check that, though, is kind of the hard part. I think what I'm going to do is I'm just going to literally print out when we finish a frame and have that be it. Oh, we already do. Okay. So let's just do 2 threads and then see what we get out. Okay, so okay, so it is always 2. It is always 2. So at least we know that that's working. I was expecting it to be like, you know, it goes again here or something, but it is they are synced, so that's fine. What isn't fine is I wonder if there's something that I deleted here that was important. Shit. It's only happening with the other ones. It's not happening with our main one. So I almost wonder, so let's try something. Let's just read from cell FFT instead of the everything else. Let's just have 3 views that are exactly the same. The same issue happens, yeah. Yeah. How did I get here? I don't know. The algorithm works in mysterious ways. Yeah, so it's not that. Huh. Hey, what's up, Andre? Persisting data. Yeah, it's strange that the... It's a threading issue for sure, but like, how? Yeah, I've got everything threaded now, and it's like 30 FPS. The issue that we're running into is these borders. Do you see this border here that has this sort of glitching out thing? This gets exacerbated when we have more stuff going on. So you get these borders that are just like flashing for this one part on the edge. And it only happens when multi-threaded. And I'm fairly sure that this didn't happen before. But I was trying to implement the thing for my kernel. I was trying to implement another 4th view for my kernel, and I touched something and probably fucked it up, to be honest. So yeah, all of that is completely, that is all normal. I mean, I could try going back to 36 like we had it before, but yeah, the reason why we don't have it at 36 anymore is because we ran out of memory. So why is bro on Windows XP? Be getting privacy through obscurity? I'm not sure what that means. I'm not connected to the internet. Yeah, exactly. So we run out of memory there, which is why I switched to 15. So that's what I did there. Other than that, I didn't touch anything in there. I did move that to that. I put in this array called real K, which is literally just an array that has the centered kernel so that we can render it. Other than that, all I did was this. And I swapped the order of this so that it could be better cacheway, and that's all I did. So I don't think that it should be that big of a deal. I don't know how this real K could be a problem, but we can get rid of it, I guess, for now. Just to see, I don't know, maybe my mem set is going over some memory and corrupting some shit. I have no clue. I have genuinely no clue. This is definitely divided by a grid size. Yes, it has to be. It's absolutely divided by grid size. Yeah. And we put it into HC, which is now taking the place of G, and we accumulate that into here, and then we just add it here, and that's our growth step. And that should work fine. But it doesn't work fine. Tried using RenderDoc? No, I haven't used RenderDoc. I don't know what it would take to get RenderDoc on this thing, but maybe I should give it a shot. I don't know if that's... I don't know. I feel like it's gotta have something to do with... Yeah, it's still happening. It's weird because it's every other frame. I mean, but it's also there during the first frame, but... It's weird that it persists, you know? Because we clear the buffer, so... I just don't understand. I don't understand. There was a problem when we switched to the smaller buffer, but I don't know. Yeah, and now we're just not going to have enough stuff. So, I think, to be honest, what I'm probably just gonna do is straight up just press Control Z to figure out what I messed up on this. So that's just what I'm gonna do. Just like the only thing I could do. I did put that there, but we also commented that out, so can't be that. What's the source of what exception? That when I quit out? It's just because I shift F5. That's why. It's not actually a crash. Yeah, I'm interested. What did I do before this? I commented that back in because we got rid of it. I'm pretty sure at this point it worked. I'm like fairly sure at this point it worked. No, it didn't work. Maybe it existed from the beginning. Yeah, I don't know how I didn't see it. But I feel like this wasn't happening, but... Yeah, maybe it did exist from the beginning. Okay, so here's what we do know, right? Like, so this is definitely, we tried it single threaded, so it has to be a threaded issue. Okay. I'm just laughing at the Rob thing. It's pretty funny. So it's definitely a threading issue, and it's a problem with the borders. You should use your backup codes and check it. I don't know. I feel like this is just an issue with the new multi view thing that we did. I don't think that it has, because it's not inside of the regular quadrant of the cell. It's on the other quadrants that the problem is. So I wonder if we didn't like think about this and we're somehow like doing some undefined behavior. By the way, this B offset is very like suspicious to me. That B offset is basically where our thread lives in a buffer. The B offset is computed by this times max channels times 3. So that's correct. The calculation is fairly suspicious though. It's just a very suspicious calculation. Let's just try. I want to try and see if I can like give it. Can I give it extra space? I think I maybe I have enough leeway to give it extra space. I don't know. No, I don't think it's running out of space. The thing is, this B size calculation looks really suspicious, but it actually works. So the interesting thing is that this never exactly lines up, right? So mathematically what's happening here is that we're setting ourselves to negative grid width times cell size divided by 2, which is basically saying like, hey, we have a certain, size of our, voxels, right? And we're going, negative divided by 2, right? So that we get centered around 0, 0. So that's what this is, right? And so when this goes down here, basically we're doing divided by 2 to divided by 2, right? This might get no, but if it's 32 divided by 2, that's always going to be fine. That's always going to be fine. And the cell size is 1, so it would never be a problem. So it can't be that. Now, yeah, it's always going to be on a correct boundary, and this is -1. So in practice, this is actually just like what, 16 minus negative 16, which is 32. Wait. Oh yeah, 32. That's the amount that's inside of it. Oh yeah, but this is because of this. So you have the step, which is this divided by max threads, and so in this case that it's 2. This is going to be that's going to be 8 minus, or no, this is going to be 0 minus 16. So yeah, or yeah, minus negative 16, and then you get, yeah. So that's correct. Wonder if I can try like not mem setting this or something, or I don't know. I'm just looking down here because I know I played around with some stuff down here and may have just overlooked something. Just making sure that I index everything properly. Really, also, I should never call this TD. It should be T. It's annoying to refactor it, but TD is also a global variable. The reason I didn't was because of the timer, but I'll just rename that now. Yeah, it's important for me to do it that way. I think the only point where I get it is down here, yeah. Yeah, I'll probably figure this out later, but what the hell? I obviously missed a T here. Yeah, I missed a T there. Okay. Wait, what? Oh. I did miss the most important T to miss. Yeah. It is happening inside of here, though. Yeah. Here's what I'm gonna do. I'm just going to render the main view and see if it's persisting. It is. You know what I'm thinking? I think it might be the shit that we did here, dude. I think that it may have been me changing G and stuff. I think that may have been the problem. But now I have to refactor everything again, so that's kind of like an absolute pain in the ass. I think it should be fine. Should compile. No, it isn't. I'm telling you that something isn't getting set to 0 all the time, and that's a big problem. Yeah, I mean, we can't really go back all of this, so... Man. What a day. What a day. Today was fun. Find my macro. I'm not undoing it. I'm not undoing it. Something is not getting set to 0, I think, or something. It's like some data that's like persisting that... Weren't we supposed to like... Hold on a second. I set this back to 0. I set this to back. I set grid. And I do go to max channels, not channels. That's what I was checking. I don't actually 0 this, do I? Yeah, I don't go cells I dot back C equals 0, do I? Okay, well, I really thought that was gonna be it, to be honest. I mean, at this point, I'm considering, Oh shit, hold on. This doesn't go to max channels, so let's just, for the sake of argument, let's just go to max channels on everything, just to make sure this will run really slowly. No. No, not that either. The fuck? Yeah, I can't like lose my head here because it is a multi-threading thing. Like it doesn't happen when we aren't multi-threaded. So like what am I even fucking doing right now? Like it doesn't happen when we're not multi-threaded. So oh, it does happen. It does happen. Like that. Beginning? Is that the name of the art piece? Okay, now it seems to work fine. So just zeroing this is good. Zeroing this is really good. The problem that I have with the whole zeroing this thing is that it doesn't fucking work when we're not multi-threaded. So there's that. Wait a second. I did have this. Don't be stupid. I did have that. And you're stupid if you think otherwise. I did have that at some point. We did get rid of it. Oh my god, I'm gonna fucking lose my fucking shit. Fuck. Wait, are you... See, I think that's a regular flash. Like, that's actually, I think, a flash. Like, that's, like, kind of... Maybe it's not. I don't know. Like, that's a real flash, I think. Like, there's... That's just it being that volatile. Okay, so you're telling me that was the bug after all of this shit that we just went through? That was the bug. Really? Turn on VSync? It is on. It is on. Okay, so now with the other views. Oh wait, we don't have the other views. I didn't change the number back. Okay, so you're telling me that it was just that we didn't memset the fucking thing? Is that what you're fucking telling me? Oh, that is what you're fucking telling me. Brother. Dude, this is why I fucking hate graphics programming, dude. That's why I hate fucking graphics programming. Because it's like, Oh, man, I must not have zeroed an array, bro, that I was accumulating into, and blah 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 blah. And it's fucking like, no, no, it's none of that. It's just that you forgot to memset the draw buffer. That, to be honest, should be memset for me if I'm being real, man. I'm gonna just keep it real, man. What's up? What's up, bro? Not much. Just coding. Okay, can we turn the kernel back on now? Can we turn the kernel back on now? Said Linus Torvalds to the Linux. Can we turn the kernel back on now? Can we turn the kernel back on? Windows XP, wow. Yep. Exactly. Exactly, wow. You'd be surprised. Windows XP is not very popular with the kids nowadays, dude. It's not. It's not. You'd be surprised. I get a million people in here that are like, Windows XP? Oh my god, grow up. Something like that. I thought that we were like nostalgic or some shit. Like what is the problem, bro? Whatever. At least for us, yeah. Windows XP source was leaked a long time ago. I heard somebody said that there's like a there's a Windows XP distro or some shit for Linux or something. Somebody was saying that. Yeah, so rebuild kernel mesh, I think I called it. Yeah, damn right I did. Okay, what? Okay, I'm gonna keep it real, bro. You better allocate the fucking buffer or else I'm gonna drop kick you. What do I gotta do to make you fucking allocate the buffer, brother? Okay. Times 3? No. Because this is for 3 views. This is just the last view. I think we're just literally out of memory is kind of the sad thing about working on Windows XP, but yeah, you know, we can try like we're never gonna have that many vertices. Let's keep it real. We're never gonna have that many vertices because of, you know, reasons. Because it's not that big, right? And so we could just cut it in half. Bro, like, and like, oh, hold on. Well, yeah, we can't do that. That's something that we can't do. We can't do that. It wasn't that it was times 3, it was that it was not times 3 and I was multiplying it times 3. That was the problem. So the problem was that I was also the problem, like you're the problem, right? You feel me? Okay. You know, it's pretty dark because of the lighting, you know, but that's the kernel. Okay, it is kind of tiny, right? But the cool thing, we can make it bigger in real time. Holy shit, watch this. Oh shit, it's getting bigger. It's getting bigger. It's a massive kernel, bro. The craziest kernel you've ever seen. Look at that shit. Massive. Absolutely massive. And so you see the rings inside, right? You see these rings inside? That's the beta. That's the beta that we were talking about before. And the cool thing about this, we can go boop, no beta, and then you see how that ring disappeared? Those rings inside are those. Why is black? Because that's the color I chose for it. What, you got a problem? You got a problem? You got a problem with that? Let's make the fucking red one bigger, huh? Holy shit. Holy shit, massive kernel. Got the biggest kernel in the world, bro. I got a kernel so much that the simulation is starting to look like, I don't know. It's starting to look crazy. Oh, that was kind of cool. What are the blobs doing? Max thread is 2? No, it's 4. I put it to 4. I'm actually pretty happy with the performance. I mean, we only lag when I press tab to rebuild the field. We're kind of not lagging that much. I don't think we're 30 FPS. We're probably like 25-ish. Something like that. But we haven't simmed yet. We still haven't simmed. Now why haven't we simmed? Oh, we haven't simmed because Dustmite is a freaking loser idiot who didn't read Computer Systems, a programmer's perspective. That's why we haven't simmed yet. Because Dustmite can't fucking read. But that's kind of sick though. You gotta admit. That's kind of fucking sick, bro. But come on, man. But come on, man. That's fucking sick, no? It's like the sickest thing ever made, or what? I know that, like, I've only spent like a week making this, but I feel like this is probably one of the sickest things I've made. I gotta get some shaders in this shit. Let's go for a 60. Is the UI React? Bro. Give this guy a comedy gig. I wouldn't even come up with that. That's fucking hilarious, bro. It's the UI React. Oh. I'm gonna put this shit on my React job application. How is it so fast now? Because I'm the GOAT. Or what? Okay, I'm not the GOAT, but you know, a lot of pain and suffering. But that's alright. I streamed all of it, so it's proof, you know, of my, like, you know, it's pure HTML. Bro, just wait till they figure out that this is actually in Java and not in C. This is just a wrapper over Java, bro. That's why it's so fast. Holy shit. That one's funny. Okay, this one lags a little bit. This one lags a little bit. I think there's a lot going on in this one. This one's a bit. This is a bit challenged. A bit dense. I also, the random kernels that I generate, by the way. Oh, what is the kernel size on this? That's the kernel, by the way. The kernel has a radius of 1. Oh, also the kernels that I generate in the random naturally have like really small radiuses. Which I should probably change now. Kernel radius isn't really the bottleneck. We can have kernels that are much bigger. So, by the way, this function is what generates the random stuff that that you've been seeing when I press the R button. That's what all this shit happens, right? And so we can like straight up put this to 10, and we can bring that to 4 channels. 4 channels might actually break things, but why not? The neighborhood can get bigger because our thing is bigger, and our time step can be bigger. Actually, yeah, let's make the radius 8. The neighborhood, by the way, is the, you know, what I do instead of just like putting a random data in the grid. What I do is I just choose a neighborhood, of like a blob to like put shit in, so that it like can make life instead of just a bunch of random noise. I'm glad that you think it's sick. The settings are not 30 FPS. Yeah, so I probably did the painting wrong for it. So I'm not really sure. Oh shit, that's the 4th channel there. That's the 4th channel. It's super laggy with 4 channels, of course, but that's the 4th channel. It's black. Oh. Okay, yeah, we tried 4 channels. There's probably some... I probably have to refactor something. Technically, it should be able to go to 4 channels, but probably something is... Yeah, so my painting, whatever I did to paint it, was probably not the correct way to do it. I looked up how to paint window white, or paint over window, and then it told me to do that function. And so I did that function, not really thinking that the consequences would be this bad, but... Yeah, that's pretty cool. It's a lot cooler with the bigger kernels. Oh my god. Why? But like, what's the problem here? Tell me how I made it so fast in the last 2 days. Well, I sit here for like 12 hours a day and like bang my head against the wall while I have like children come in and like throw tomatoes at me. I think it's pretty sick. Is it the neighborhood? Time step? Like what? Oh, maybe it's kernel radius actually. It was the triple necessary. Yes, exactly. Exactly, bro. Oh, wait, kernel count, maybe. Oh. Huh? Oh, kernel count. We may have gone over kernel max. I really wanted to get it bigger. Oh my god, bro. Like, what is the problem, brother? What is the problem? What is the problem? Why is this like crying over like spilled milk? Like, bro, chill out. Chill out. If I really have a neighborhood of greater than... Really? Really? It's the neighborhood that's the problem? I want to have bigger kernels, bro. Because bigger is obviously better. See all that blob, bro? That's a big kernel. Okay, we have the kernels are fine now. Okay, so it must have been something else that I changed. Yeah, the big kernels are so sick. Because you get to see like really crazy patterns start to pop up. You do have the flashing though, but that flashing is legal. It's completely legal. It's so sick, bro. Dude, like, you see those, like, in video doing the fucking, like, fabric simulations? Like, get out of here, bro. I got that shit on Windows XP. Okay. That's cool. That is really neat and cool and fun. Bro did it on DirectX 9. Yeah, exactly. Don't need anything, bro. Okay, so you know what I'm like, you know, after having all this triumph and win, I really want to get the complex multiplication happening, brother. I need to get the simmed working so that I can sleep tonight and sleep happy. And I just don't think that it's working, brother. It's hard to tell, but it just isn't the same. It just isn't the same. Please push to Git after you're done. Yeah, everybody keeps on asking me, "Oh, make the code code public, make it open source." Like, bro, you're telling me you're gonna fucking download Windows XP to do this shit? You're like, really? Because I don't think so. I just don't think so. I just don't think that that's gonna happen. I will not, but I want to read it. Well, if you can read Rob's fucking macro here, I think you get a good idea of how shit this thing is. Okay, so I think that we need to step through this again. Okay. So we have T times kg, which is kilograms, okay, minus T times kg. Okay, this is the real minus the imaginary. Okay. Then we put that into the real. Okay, then for the imaginary, we have the real times the imaginary plus the imaginary times the real. Okay? That's what complex multiplication is. Okay? So that's what we gotta step through here. And we gotta figure out how to do it, okay? Because I'm gonna lose my fucking mind if we can't figure this out, okay? Oh yeah. We gotta let it go until it gets a thing. Okay, so it has a thing now. So we're just gonna break point it. And we're just gonna go through, okay? We should have asked while fucking Andre was here how to do this shit, because he would probably know. That guy's like professional or whatever. 6631 Okay, so A1 is our T. Okay, A1 is the T. Let's get it right. We load it in. That's 6631. Okay, 6631. Over here is 0.99. Okay. Okay, so what we want to do is 6631 times 0, okay, times, no, 0.99. 0.99. There's no imaginary in here, is there? Yeah, there is no imaginary. So I feel like this is probably like a shit place to breakpoint it, so we're just gonna keep going. We're just gonna keep going. Okay. This also has no imaginary. Yeah, man, we're just fishing and nothing is coming back, you know. Brother, like, can I please get like, okay, there we go. Finally, fucking finally. 1397 137. 0.9 and 0. Okay. So we do the multiplication between A and 0, and that's what this is, okay? So we're multiplying the real, and then we shuffle and then multiply the imaginary, okay? So we multiply the real, and the real, once again, is 1397 times 0.94. So I should see 1316. Okay, so far so fucking good. Okay, so we did that. Okay, this is the real. Okay, and then this is the imaginary. Okay, lock in. Okay, because this is the tricky part. So we shuffle this. Okay, so this is 0.9. And now all we... Yeah. This is fine. 0.94. And now what we want is 0.94. Yeah. And we get exactly that. Okay? We get exactly that. So what we want to do is we're multiplying the imaginary, okay, which is 137 and 0.94. Okay, and we get that in BM. That is there's negative 129. Okay, that's negative 129. So now we need to... Wait, hold on. I think I just figured out the bug. Okay. We need to just subtract those two. We already did this shit. So this is... Wait, hold on. Why is this BR? Oh, BR is the... Yeah. This is stressing me out, man. Lock in. 0.94. Okay, so that's imaginary. And then this is the 137. That's absolutely the 137. Yeah, that's absolutely the 137 that we saw here. Okay, so we multiply them, right? And we get the BM. And so now all we need to do, we have the 129 is the BM, right? 137 times 0.9. Hold on, isn't this supposed to be 0 imaginary? Or am I tripping? That is supposed to be 0. Huh? Wait a second. You don't need a shuffle at all here. You don't need to shuffle at all. I think that we just have like the stupidity inside of us. Wait a second. We already do the multiplication for both of the numbers, bro. Like 137 times 0 gives us 0, bro. It's already inside of AM. All we have to do is add them together. So what the fuck were we thinking? Like, what were we smoking earlier, dude? I don't know what the fuck we were smoking earlier. So when we do BR, we get 0.94 in the second part. Okay, so we need to get it to the first part. So that's what this does. So we just put in AM into BR, and then we just add them together. We just straight up add them together. And then what we'll get in this case is the 0, which is the imaginary, plus the 1316. Right, because we swap them, we swap the imaginary, and then we add it to the real. So in this case, we would swap the 0, and then get the 0 here, and then add them. And then we just want to take the... Oh wait, no, we subtract them. Okay, so this is sub PS. Oh wait, we just wrote exactly what we just wrote here. I just wrote the same thing. Okay, hold on. Okay, hold on. You still need B0 to be swapped. So that you can do the bottom part. Okay, let's walk through it like this. Okay. Man, this is so complicated. Yeah, so we swap them. Yeah, that's good. That's good. And then you subtract. Right? Yeah. I'm totally with you on that one. And then you get that. Yeah. And I add is 0. Why is I add 0? To be honest, it kind of makes sense in this case because the imaginary is 0, right? Right? The imaginary is 0. Okay. Okay, I think I'm just gonna send it. And let's see what happens. Okay. Okay, now let's just like compare side by side to see. Yeah, it isn't the same. It's barely not the same. It's barely not the same. It's different. It's different, man. Okay. All right. Maybe I gotta do this later, dude. Oh, man. I don't know how to do this. This is hard, man. This is hard because we don't have horizontal addition and subtraction and shit. So it makes this like 20 times harder. You know. And 20 times is a lot of times, it turns out. Like that shit is a lot. Okay, we gotta get some imaginary numbers in here. Alright, we got some. We got some. Okay, so this is the real. So 280, yeah. So that's good. Then this is the imaginary, right? So we want 0 times 0. Okay, so we have the 0. The 0 times the 0. Bruh. No, yeah. We already did the 0 times the 0, so this is just, you swap it, and then you just add them together, subtract them. Maybe the loop is wrong, and the complex function is right. And you did what emote? Is that a guy with a blindfold that has a question mark? That's crazy. So this is also something that I thought, right? So listen, hear me out, right? So we are going to grid size, okay? So hear me out. We do this, right? And we do this. And it loads in 4. It loads in 4. Do you understand what I'm saying here? It loads in 4 into here. Even though it only has space for 2 at the end. Do you hear me out? Do you hear me out on that one? Unless store UPS stores 2. You know what? We could like do a quick Google on that. I think it does store 2 actually. I think I'm just stupid. No. It says store 128 bits. Brother, 32 times 2 is 64. Shit. You know what I'm thinking? You know what I'm thinking? I'm thinking we should have done this. I'm thinking we should have done this. Like, we avoided this because it would be complex. But now it's telling me that there is no, that you gotta do all of them. You gotta have 4. Do you feel me? Do you feel me on that? But just imagine how fucking complicated this is gonna be if we do that. The good thing, so the good news here is that this is all of the first part. All we have to do is add them together. Or subtract them. Subtract them. The issue is that we have to do this shuffle bullshit. Which we already know how bad that is with 1. And now just imagine how we have to do it with... Okay. Let's lock in. If the order is consistent, then technically that should be fine. Brazil. Bro, did I just get it the first time? No, I didn't. Fucker. I almost got it. I feel like it. Yeah. Shit. No. It's gotta be that or something. Wait, what do we even want to do here? Okay, so hold on. So we have this and that, right? And we multiply them together. That's just like clockwork, you know? That's a given. Okay. So now what you want to do is you want to subtract them from one another, but not that. So you want to get the 26 into position 2 and the 488 into position 1. Okay? And so we didn't do that. We almost did that, but then we didn't do it. 4 int I equals 0, I less than 256, I plus plus. Are you good, bro? Are you like hallucinating, bro? What are you talking about? What are you talking about? Are you good? What? What are you talking about? Are you good? Stay with me, bro. Hang on. We're gonna get out of here. You gotta chill, bro. What are you talking about? It's one of these. It has to be. To all of you. Bro, like, what? Now it just stayed in place. Oh. No. No. That it cannot be that. If it's that, that's seriously fucked up. If it's that, it's seriously fucked up. I don't understand. Maybe I'm stupid and I don't understand how the documentation would work. Okay, but why is that duplicated now? Now just put a 0 there, bro. Oh my fucking god, dude. Fucking Christ, bro. You gotta be kidding me. Oh shit, bro. What's the idea? Yeah, you're telling me, bro. You're speaking my language right now. What's the big idea? The big idea is that we're trying to do a simmed. Okay, we're trying to do some simmed instructions. We're trying to switch. We're trying to do a bit of a shuffle here so that we can get boom, 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 boom. And we just did it. Okay, but we got to do 2 more. Okay, so now we can subtract this from that. Absolutely. Yeah, absolutely. So we get that shit, and part 1 is done, okay? Unfortunately, that's the easy part, okay? Because now we're about to lock in for the hard part. Also, okay, so we have a data layout of 0, real, imaginary for the second set, okay? So the next part, so we have this, okay? So the next part, we gotta somehow slot this shit into here and do like a little bit of a, double shuffle, okay? That's the hard part. Okay, that's the tricky part. Okay, lock in. Okay, so now what we're trying to do is we're trying to do this part. So we're going to do real times imaginary plus imaginary times real. Okay, that's what we're doing. Okay, listen. So we take the b, okay, which is the kernel, okay, the kernel. Okay, so we take the b and we want to do a swap so that we can just multiply across, okay? So now we need to do, actually, this should be the exact same pattern as the other shuffle, okay? You know what I'm calling this shuffle? I'm calling that shuffle the dust mite. You can name that shit after me. I need to finish this. Yeah. No. This is absolutely correct. Absolutely. Yeah, you just swap the other one. Okay, you just swap the other one. And now you just gotta add them together. How do we add it together? My palms are sweating? Yeah, me too, bro. Me too. Okay, so we did the shuffle. We did the shuffle. The fucking Sharima shuffle. Uh and so that real times that imaginary, and then the imaginary times the real. Yeah. So that works out. That works out perfect. And so we get that. Now we need to add, but we can't do horizontal addition. So we need to do another shuffle. Wait, bro, played League of Legends. Yeah, bro. Okay, so we need to do yet another shuffle. We need to actually shuffle it back exactly like we had it. Am I a genius? Yeah. You're shuffling it back. You shuffle it back so that then you can add straight across. Okay. And you add straight across. And then... Yeah, but is unpack low PS going to actually... Like, what is res here? Alright, we'll cross that bridge when we get to it. Okay, hold on. Lock in. I think we just did it. And by we, I mean me. But, you know. I feel like that doesn't look right, but I don't, like, give a shit. But whatever. Right? Okay. Okay, so the ad needs to go in the upper portion. Okay, so it needs to be 0. Yeah, that negative 2999999 is not a thing. Right? Yeah. The result should be, yeah. No. 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 Oh my god, bro, fucking crazy. Okay, so we can't do unpack low. We need to look at the other unpacks. Unpack PS sim. There is one. I think we might have to do another shuffle, bro. We only care about the first. We only care about the first, right? Yeah. So we only care about this and this, okay, in either of them, right? So we need to get this and this over to this and this. So that means we need a shuffle. This is the craziest shuffle of all time. We're gonna call it the final shuffle. I feel like there's gotta be an easier way of doing this. Nah. We got a final shuffle. I need to unpack all. How do I unpack everything? Hold on. Store UPS? Maybe I don't have to unpack. Maybe I just straight up... but I got it in 2 different registers, bro. Yeah, shit. Definitely final. Dude, maybe we gotta shuffle again, bro. No, we don't have to shuffle again. We just need to combine them, okay? So we need like a pincer motion. Because we have this and this, and this and this. And so they need to go like this. You see what I mean? How do we do that? Is there a way to do that? Not shuffle. No, store. They gotta have done this, bro. Nah, it's actually crazy because we have to redo this shuffle and get everything into the low bits. No, bro, it's so fucked. Wait, but like... Nah, it's so fucked up, bro. That's fucked up. That's fucked up. That's fucked up, bro. It's so fucked up, bro. What's in the box, bro? What's in the box? I don't know if I'm gonna get this, to be honest. I think that, yeah, I think that this F sub, you need to shuffle this so that the third goes to 2. And then so when you interleave them, right, this F sub, that 2 would go to 3. You see what I'm saying? You see what I'm saying? And so I feel like you gotta shuffle again. Oh, but how do you do that? Because it's not the same pattern, bro. You gotta just bring 3 down to 2 and keep everything else the same. 3 down to 2. How do we do that? That's gotta be like this, right? Right? That's gotta be like that. What the fuck, bro? You typed this shit out? Shuffle. What the fuck are you... I'm trying to read it, bro. Add sub PS. Dude, maybe he's right. Wait, maybe he's right. I think we're at the point where we give it a shot, bro. I think we're at the point where we give it a shot, bro. What do we think? Let's give it a shot. I mean, bro understood the assignment. I mean, it can't be that simple though. I feel like it can't. We would have figured that out before now. But then again, it's not every day I'm doing simmed, so let's see if it works though. I mean, this is gonna be the craziest. Okay, so hold on. So yeah, this is the regular multiplication. So that's perfect, right? That's normal stuff. Add sub PS is doing everything that I needed to do. Really? I did not see this function. Alternatively, add and subtract single precision elements in a to from packed elements in B. You're telling me, boss. Alright. I need to eat some dinner, but I need to get this done first. Okay, it doesn't exist. Yeah. Our fucking, our header is too old. Yeah, our thing is too old, bro. But that's why we can't also do horizontal addition either. Same reason. Yeah, I'm SSE too. Unfortunately, that's a Windows XP experience, bro. I feel like this is still, we could still swing it though, right? Like if we just add, what if we just add them and then subtract them and then do a shuffle? Right? Like just the fuck is that? Bro, what is that? I don't know what that does. I need to try that. Negative 0.0 F, positive 0.0 F, negative 0. I think he read the book, you know? What is happening? I don't know. I feel like bro's gonna like ask me. Oh wait, but how do we then how do we get it into res? The thing is, I don't even know. Wait, so this is this? Wait. Okay. I mean, I don't really know how to store it out because I don't know what order we're. Oh, are you kidding me? That's not a thing either. Okay, no, it's this. You add and then, but then what about the subtraction, or is that the thing? Oh, I see. So that's what's going on. Oh shit. Oh. Okay. So yeah, this is prod 1 and prod 2 is fine, but then so we have this and then it switches the signs. It doesn't look like it switches the sign. Oh, well, we don't have it. It's just gonna show this, but yeah, sorry. Okay. Okay, well, okay, I think it worked. Okay, yeah, it worked. I'm too tired to really like think through if this is going to work, but we might as well just fucking send it, I guess. I have no clue. I have no clue. It's definitely, you know, it's definitely better than what we were doing. I don't know if this is it. I think it might actually be it, though. I'll need to check later. I'm not really sure. I think this might be it. Yeah, I did. I did use the sign mask. It did swap the signs. That's crazy. I would have never thought to switch the signs like that. But then again, I've never done like sim like that before. But I mean, thanks for teaching me about that sign mask thing. Like, I just know like the basic kind of load, add, and subtract, you know? So anything beyond that, I'm like kind of fucking clueless. And that's what I've been, you know, struggling with today. Trying to implement that. So I don't know if this is it, because we got really close before and it was like barely off, but I think this might be it. So this is a short thought. Yeah, I'll test it later, like when I'm like more, I've just been here for way too long, and so I'm just not like thinking straight about it. But yeah, I'll give it a shot later. Yeah, exactly. Yeah. I think what I'll do later is I'll just like literally make a function that just like literally, you know, compares the two arrays. So yeah. All right. Well, I will see you guys later. I'm gonna probably hopefully go to bed early today because I've been like fucking staying up working on this for days. So I think it's good. I think I have to do more simmed and stuff like this to get it faster. So thanks for hanging out and stuff. Peace out.